Hello Aishwarya, Dark Matter, Clay Tsunami, Music Stories, Maheshwaran, Yalini, Vamsi, Pawan. Good morning everyone. Good morning, Devdatta, Mayank. So I just had a small technical error. So probably, because we are streaming right now both on Catalysis as well as Enthuse. So there was a small trouble, but now it's rectified. So I hope you guys can see me properly and hear me loud and clear. Thank you guys. Hello Ankit, hi Manan, hi Alan, hi Indigenous Stars, hello Vasant, hello Sanya, hello Shanmukh, hi Jacob, and welcome to the Rank Booster series. So the good news is that the fourth attempt has been postponed, like most of you already know that, and now you have even more time for the fourth attempt, but does not mean you become very relaxed, because now you need to put on your full energy on the third attempt, because remember, you cannot completely rely on the fourth attempt. So make sure that you give in your best. Think as if the July attempt is your last attempt and try to score as much as possible. Thank you, Samla. Hello, welcome Tanya. Hello, Virat. Hi, Ashwin. Hello, Anishka. Good morning. So I'm Shreyas, I'm the physics master teacher at Vedantu, and I not only teach on the Enthuse channel, but we also are doing live streams right now on Catalysis, and I also teach on the regular paid platform. There are lots of micro courses available of mine which you can join. Once you're a pro member, you can go ahead and check it out. Before we go ahead, do remember that you can get to know more about me and you can get in touch with me on my Instagram handle, that's Shreyas_Vedantu. Having said that, let's also tell you one more thing, and that is about all the toppers that we have produced, and it's also a good time to congratulate them. I'm pretty sure right now they are busy studying for their advance, because they have got some amazing percentiles, like you can see out here: 99.96, 99.91, 99.97. These are all Vedantu students. Let me tell you, 1 in 2 Vedantu students has already qualified for JEE Advanced. A lot of them with very good percentiles who have already started their preparation for Advanced. So if you want to start your Advanced preparation and you want to clear the JEE Mains with really good percentiles, so that you secure a seat in some NIT or some triple IT, and you can see we have been doing consistently better than the rest of the institutes, 6 to 7 times better performance of the Vedantu students as compared to other institutes or students who did not undergo coaching. So go ahead, check out the crash course, because now it makes even more sense for you guys to take up the crash course with the test series, 11th and 12th standard material, and the assignments, especially for the fourth attempt. So give in your best, use the mock test how much ever you can for the third attempt, and the remaining mock test you can use it for the next attempt. So remember, the crash course is right now 40% off. So instead of 10,000, you just pay 6,000 when you use the coupon code SHCC. So make the best use of the crash course right now. So this 28th June also you can join, the 5th July also one you can join. You'll get all the recordings, and all the classes henceforth will also be live. Okay, so let's get going, guys, with the first question coming up on your screen, and there we go. So the equipotential lines are shown. The following, which of the following would be the best representation of the field at that particular point P? So Bugata, at this point of time, for all the students who are just going to write the examination, it's not a good thing to actually sit and go through the theory. It's a good time to actually go through the problems. So what we'll be doing is we'll be seeing the problems, and based on the problems we will be looking at the concepts. So problems and concepts, that's how it goes. Okay. Hi Gopi Krishna. Hello, good morning Nandela. Hello everyone. Sure? Okay. Most of you, I think, are wrong. Understand, these are nothing but equipotential lines, because 6 volt, 10 volt, etc. are marked, and the question is to figure out the direction of the field. Now the correct answer for this is actually C. Many of you told D, some of you are telling C, which is very good. Remember, electric field, all right, the direction of the electric field always goes from high voltage to the low voltage. Now you can clearly see this is nothing but high voltage. The 6 volt line will be like this and it will go like that. So this point over here will be obviously low voltage. Always remember, field goes from high potential to the low potential. So that's why the direction of the field will be towards the right side. In fact, there is a formula for that also. Electric field is negative dV by dx or dV by dr. This negative sign tells us that electric field is always pointing towards the lower potential. So what is the significance of this negative sign? The direction. It always goes from high to low, not from low to high. So it is it is always pointing towards the potential which is lower than the previous one. This dV by dr is also called as the potential gradient. This is also called as the potential gradient of that particular electrostatic system. So keep this in mind. Very simple question, but if you know the concept and the theory properly. Oh my god, Sania says -1 at the beginning, Pramesh got +4. Dinesh, it will be better if you take a screenshot later on, bacha, because what happens, there are a lot of things which I tell on the board which probably cannot be printed. Some of the questions, yes, there are printed solutions, but you know, there are a lot of things which I would tell which I cannot put it in writing. So it's always good to probably go to that particular point of YouTube video where the teacher was explaining that particular question, if you don't mind. Okay, cool. Chalo. Hello Vishruta, welcome aboard. Come on, let's go to the next question, and here it is. There are two equal negative charges, negative Q and that's the value of the charge, and the points are 0, A and 0, -A. On the y-axis, a positive charge plus Q is released from rest at a point 2A, 0. On the x-axis, what do you think the charge will do? It will execute SHM. Will it move towards the origin and remain at rest? It will move towards infinity on the other side. They execute oscillatory motion but not SHM. Okay, A, B, come on my warriors. Lit Lucifer, depends bacha which NIT you are talking about, but usually most of the NITs that you would be applying to will be 100 times better than Manipal University. So obviously usually 99% of the times NIT will be a better choice, but let's focus on the slides and you know, this current session right now. If you have any specific doubts, you can definitely leave a comment below or ping me on my Instagram. I'll definitely respond to that. Aditya saying C, interesting go. Let's see. Well. Okay. So guys, the correct answer is actually D. A lot of you got it wrong. Some of you said A also. I knew most of you are going to tell this. That's why you will get negative marks in the examination. That's why the rank booster series is important, so that you understand the actual concept. Many of you would have made this mistake. See, there is a negative charge here and here on the y-axis. So this is the y-axis. Okay, cool. So this is our y-axis, let's say. And on the x-axis, at some distance, let's say, there is a charge Q. Now what will happen? This negative charge and this negative charge will apply forces. One force like this, one force like this. Their resultant force will be along the x-axis. Okay, this is the resultant force, I would say, Fr. And let's also assume that this angle is theta. Naturally, this angle will also be theta. Now, isn't it obvious that the resultant force will be this force of attraction's cos theta component, because the sin theta and the sin theta components will cancel out each other. So these two cos components should add, and hence it will be F cos theta, but there are two forces like that, so 2 times of that. So it is actually 2F cos theta. Now, what exactly is the value of this F? If you observe carefully, there is a nice triangle which is formed where the base is x and let's say the height is a, okay, and this force is along this direction where this is theta. Now think about it, what would be this distance? Because it's the hypotenuse, it will be root of a square plus x square. So the value of this force will be some constant into QQ divided by this distance square, which is a square plus x square. Okay, so this distance between these two charges is root of a square plus x square. So electrostatic force, standard formula, kq1 q2 by r square. Therefore, this F is nothing but kqq divided by r square plus x square into, look at what cos theta is, adjacent by hypotenuse. Adjacent is x and hypotenuse is a square or whatever this, a square plus x square into 2, of course. Now my point is that if it is a SHM, this is very important guys, I don't know whether you know this, if it is SHM, remember the force is always proportional to x. Observe carefully and tell me, is the force proportional to x or not proportional to x? Think about it. Is the force actually proportional to x or not proportional to x? Aman, the class just started, bacha, and probably we just done one question. This is the second question now. Is the force proportional to x? You might say, sir, yes, no, look at this, there is x here, there is x here, and there is x here. So in this question, F is not proportional to x. Therefore, it is not a SHM. Lot of people think it is going to be SHM. Hence, what will happen is this charge will experience force. It will move like this, and by the time it comes here, it will have velocity, and because of the velocity, it will go to the other side. But as soon as it goes to the other side, these charges will pull it backwards, so it will decelerate and stop, and then again it will go back, and again it will overshoot, again it will decelerate because these charges will pull and stop, and again it will accelerate, decelerate, accelerate, decelerate. It will oscillate, but it is not a SHM. Hence option D is correct. Understand, every oscillatory motion is not a SHM, but every SHM will be a oscillatory motion. Did you guys get it? Okay, a lot of people are going to make a mistake over here. So in the set of oscillation, SHM is a subset. So in the set of oscillation, SHM is a subset of oscillation. There could be a motion which is oscillatory but not SHM. It should follow this rule. This is the important rule. If it does not follow this rule, then it is oscillatory but not a SHM. Got it? A lot of people are going to get -1 marks in the JEE examination for this question. I'm pretty sure now that you know this question and the way to solve this. So I am hoping that questions like this will be solvable by you guys in the actual examination. So whether next week 2022 class will start? Unknown Krish, yes, as soon as 2021 exams are over, we'll definitely come back to 2022 classes. Yes, so it will be periodic, Aman, correct. Okay, so when Q is kept on the y-axis at a large distance from the center, then it may execute oscillatory, but when kept closer, yes, correct. So in this question, it will be SHM only if the charges are very far and this charge is very close. So for small x, it approximately comes out to be a SHM, because that force approximately comes out to be proportional to x, because the denominator and all of that, when that x square comes, it becomes negligible and you can ignore those terms, and it approximately comes out to be SHM for small displacements. That's why you would have seen in your books or tatva or assignments or mock tests, there were questions where, you know, the value of x was small and they have asked you what is the time period of SHM. The only reason is because when x becomes small, x square becomes even smaller and a lot of things become negligible. Okay, so that's how it works. Great. Chalo, let's get going to the next question. Hi Luca, hello, good morning, be a miracle. Okay, come on my warriors. Imant, you're not too late, but you have missed a couple of questions, but it's okay, you can watch the replay. Even if you are joining in late, it's okay, just continue from wherever you are joining in. You can watch the rest of the questions as a replay. Watch the remaining part live, because watching it live is very good. I mean, you will be involved, you will feel that competitive, you know, spirit out there. Okay. Hello Abhiday, Raj, welcome aboard. So there is a charge which is fixed at x0, 3x0, 5x0 till infinity, and minus q is placed at 2x, 4x till infinity. X0 is a positive number. Okay. So what is going to be the potential at the origin? Oh, all of you are saying A only. Okay. 0 for sure. Done. Okay. Hi Nisha, welcome aboard. Okay. 0 sure. Pakka. Okay. Lock किया जाए. Done, done. Devdatta, Ankit, Gangadhar, Abhiday. Yes. Okay. Well, what if I tell you guys are wrong? Okay. I'll tell you what. See. Observe. That's why you are attending this series, guys, because you guys are going to make mistakes. I don't want you to do those things in the JEE examination. So this is the origin, okay, and let's say this is our number line. Let's see where is x0. X0 will be, let's say, here. Then this will be 2x0, and this will be 3x0, and this will be 4x0, and so on and so forth. At x0, 3, all the odd x0s, you have a point positive charge, plus q. Okay, so plus q, and so on and so forth. At 2x0, you have minus q, and so on and so forth. This continues, guys. So here is what I'll do. The potential is asked at point O, which is the origin, due to all these charges. Remember, these charges might be equal and opposite, but they are at different distances. So their potentials will not cancel out. You guys are wrong in thinking, sir, whatever potential Q will produce, that will be cancelled by minus Q. Guys, be careful. Q is at x0, minus Q is at 2x0. The distances are different. How can it cancel? So it will not cancel. Yeah, be careful. So the potential at O will be potential due to positive plus potential due to negative charges. Now, what's the formula for potential due to positive charges? Okay, come on, that's simple. 1 upon 4 pi epsilon naught. Okay, so you will have Q by this distance, which is x0, plus Q by, again, 3x0 and all the other odd numbers. Okay, it will continue. Because of the negative charge, how did this formula come? Remember, formula for potential is kq by r. That's it, not r square. Kq by r. K is 1 upon 4 pi epsilon naught. Due to negative, it is 1 upon 4 pi epsilon naught, and you have Q. It's a negative one, so I'll put a minus sign over here. The reason why this became minus is because all charges are negative, but if you still do not understand it, no issues. I'll put a negative Q over there, and this will become 2x0 and plus minus Q by 4x0 and so many terms like that. I feel I can combine them into one single thing. I'll tell you how. It will become Q by 4 pi epsilon naught. Okay, so this is 1. Okay, this is 1 plus 1 by 3 dot 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 plus this is also common. Okay, because 1 upon 4 pi epsilon naught, 1 upon 4 pi epsilon naught common. I can also take x0 common, so I'll put x0 outside, x0 from here denominator, I'll take it outside, and on this side I will have, okay, minus 1 by 1, minus 1 by 2, minus 1 by 4, and so many other terms like this. Now this can be solvable. I'll tell you how. This is Q by 4 pi epsilon naught x0, and this is 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 by 5 minus 1 by 6 dot dot dot. This will continue, guys. Now I don't know whether you know what is this. I don't know what is this. No, they will be dipoles, Lohit, but treating them like dipoles will be very, very lengthy and unnecessarily complicated. You should know this formula. You should know this formula. Well, I'll tell you what that formula is. It comes via maths. It's called the Taylor series. The Taylor series, if you remember that. So ln 1 plus x is x minus x square by 2 plus x cube by 3 minus x raised to 4 by 4 dot 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 till infinity. That's the formula for ln 1 plus x. Now if you substitute the value of x as 1, see what will happen. Ln 1 plus 1 will be 1 minus 1 by 2 plus 1 by 3 minus 1 by 4. I think I have it. 1 minus 1 by 2 plus 1 by 3 minus 1 by 4. So this is nothing but q by 4 pi epsilon naught ln 1 plus 1. I have got the RHS. I just equated it to the LHS. Nothing. So this is nothing but ln 2. So I think D option should be correct. Electrostatics, this is DR, this is electrostatics only, bacha. Okay, so this is not Gauss's law or capacitors, this is electrostatics. I started my lecture, my session with electrostatics, then we are going to go to Gauss's law, and then we are going to go to current electricity, then we are going to go to magnetism, the sources of it, and then we are going to go to the FX, we are also going to go to EMI, we are also going to go to AC circuit. So lot of things coming up. Yeah, it's not Taylor Swift, okay? But yeah, you can remember Taylor Swift, and please remember the formula. Just don't remember Taylor Swift, okay? This is the Taylor series. For everything it is there. For sin x, for cos x, for tan, log, you should know. Just search it, it will be there. Alright, so that's the answer, and that's option D. Beautiful question. A lot of you got 0, so you would have got negative marks, okay, for that. Let's do this. An electric dipole. Again a question on electrostatics. An electric dipole AB is placed along the x-axis with its charges placed at distances x1 and x2 from a very long wire having uniform linear positive charge density. Meaning this is a long wire, it has positive charges on it. You can see there is a dipole here, a negative and a positive charge. This is at distance x1, this is at distance x2. The question is, what is the net force experienced on this dipole because of this wire? Magnitude as well as direction. Very interesting question. Okay, so here is the thing. First figure out in general what's the field at any point. Reason is, if you want to find the force, I think I will need the field. And this is a long wire. A long wire produces electric field around it, and the formula for that in general at, let's say, a distance x. What's the formula for the field? The field formula is 1 upon 2 pi epsilon naught lambda, that's the linear charge density, divided by x. That's the formula for the field. Now the interesting part is, although the field will be away from the positive charge, from this linear charge, this wire, when the field interacts with the negative charge, it will apply a force opposite to the field. We know this. If you have a positive charge, the force and the field are in the same direction. If you have a negative charge, the field will be here, the force will be in the exactly opposite direction. So field is outwards, it's going away from this positive charge, but this negative charge will experience force this way, and this positive charge will experience a force that way. I'll call it F2. Now who is going to be more, F1 or F2? Think this way, who is closer to this charge? Because that guy is going to experience a larger force because of the larger field strength, because when you are closer, the field increases. So F1 is obviously more than F2, hence the net force on the dipole will be F1 minus F2. Now what is F1? Well, each of these F's will be charge multiplied by the field. Now what's the charge? It's minus q, but don't put minus q. Understand, we have already accounted for the direction. Don't do that stupid mistake, or else you'll get a wrong answer. So the magnitude of this force is the charge into the field, which is lambda by 2 pi epsilon naught. What is the value of x? That's x1 minus q, magnitude, into lambda by 2 pi epsilon naught, and that's x2. So you can see so many things are constants. Outside I can take it as common. So q lambda by 2 pi epsilon naught and 1 by x1 minus 1 by x2. There you go. Do we have it? Yep, we have it. Obviously these two are wrong because you have it on the top, but is it along positive x or is it along negative x? Think about it. Okay, Pramesh already said He got +4. Very good, Amruta. You said D. Oh, sorry. Wrong, Amruta. D is not correct. Some of you said C first and then went to D. Okay, very good, Neil, Unkit. Come on, my warriors. Negative. Why? Because F1 is more, right? So hence, this force is going to act towards the left side. Hence, this should be the correct answer. Beautiful, guys. That's the correct answer. So let's get going. And yes, there we have it. So what were the concepts? First of all, you should know the field due to a long wire. Number 2, you should know field applies force and you should know the direction. For positive, it's in the direction of the field. For negative, it's opposite to the field. That's it. And you do not need any formulas for dipole as such, and you will get it. Great. Let's get going. Very good, my warriors. If you are getting your questions right, please add +4 to your list. I hope you guys are solving all these questions side by side also. Okay, but if you still have some hesitation, or if you feel that no sir, I don't think I should be solving it right now, it's okay, perfectly fine. Just keep a notebook beside you and just keep scribbling, even if you do not get the complete question, because in the examination you will hardly get a minute or max 2 minutes to solve the questions. Let me tell you that. Okay, just watch me solve. That's also fine. It's okay. You can solve it later on also. It's up to you how you want to do it. Okay, come on, my warriors. A cube of side B has a charge Q at each of its vertices, cube, okay, and its vertices have charge Q. Side length is B. What is the potential at the center of the cube? Beautiful question. You should be able to get it. Mass blast 100 says A. Well, I don't know. Some of you are saying B. Anu saying 0. Stravani, hello, welcome aboard. Come on, think. What is the concept used? The question is potential. That means you need to know the formula for potential due to a charge. Now there are 8 charges and it's a cube, and there is a point at the center. You want to find what's the potential at the center. Remember, potential is a scalar quantity and not a vector quantity, so be careful about that. Good morning, Srinivasa. Moksha, do watch my lecture for BitSat strategy session to get above 400 on our channel. Just search Shreyas Sir BitSat, you will get the session. All right, the strategy session for BitSat. Yes, Satyanaran, the 4th session has been postponed. Wake up, my warrior. A long time. It got postponed yesterday, and we posted it on Telegram on our community, like we told you, that will always keep you guys updated. Yeah. Okay. Nishant, yes, bacha, please, you should respond, not I. You should be responding to what do you think is the correct answer. All right. So let's see how to do this. Let me first of all draw a beautiful cube out here like this, maybe. Okay. And yes. So, okay. So when you have a point at the center, what I will do is first draw a diagonal. Okay, what is the length of a diagonal? What is the length of a diagonal for a cube? Well, it's nothing but root of a square, or in this case the side length is b, so b square plus b square plus b square, which is b root 3. How does this come? Via Pythagoras. Via Pythagoras you are going to get it. Now understand, if it was not a cube, if it was a cuboid, then the diagonal length will be length square plus breadth square plus height square, root of that. So L square plus B square plus H square's root is the length of a diagonal for a cuboid. For a cube, all the sides are equal, so B square plus B square plus B square, root of that. So 3 times, so root 3 will be there as it is into B. Okay. Now why do I need that? There is a point over here. So think, what would be this distance R? This distance R would be obviously the diagonal length divided by 2, because this is the midpoint. It's the midpoint of the diagonal, so it will be midpoint by 2. So it will be B root 3 divided by 2. Why do I need that distance? Because there is a charge over here Q. So at this point, the potential at that point due to any one charge will be 1 upon 4 pi epsilon naught q divided by r, which is 1 upon 4 pi epsilon naught q divided by b root 3, and that 2 comes on the top. Now this is only because of one point. Do not forget, each point, or rather each charge is at the same distance from that particular point. You can see that all the points are at the same distance from that midpoint. So hence you will have the total potential at that particular point to be the potential due to any one charge into 8 times. So potential due to one charge was this. So just put that out here. So q multiplied by 2 divided by 4 pi epsilon naught b root 3 into 8, guys. So see, what do you get? What is the answer? Yes, are you not getting that? 2 into 8, 16, 16 by 4, that's 4. So you have 4 here, root 3 here. So hence answer A is correct. You can see that. Very good. Satvik will definitely conduct another mock test of website as soon as the JEE Mains is over. Don't worry. Alright, for now let's concentrate on the JEE Mains. Very good. Some of you got -1, some of you got +4. Very good. Those of you got +4 and those of you got -1, I hope you realized your mistake. And if you realized your mistake, how about typing it out for others? Because others will learn from it. How 8 Shifa, look at this. There is a cube and there is a charge q at each of its vertices. Alright. So how many vertices? 1, 2, 3, 4, 5, 6, 7, 8, right? That's why into 8. Sriram, you need to attend the mock tests, you need to attend these rank booster series, and you need to attend whatever formula revision, sure shot, etc. sessions we conduct. Please understand, never think, sir, I am doing only this much. Is that enough? No, never be satisfied. Always try to put in your best. Try to do as much as possible. A lot of students keep asking me, sir, I'll just do rank booster. Is it enough? I'll be like, no. Sir, I will just attend crash course. Will that be enough? No. Will only 0 to hero series be enough? No. If you have time, use that time. Why do you want to be happy about it? Sir, I just completed 0 to hero, I'm done, sir. No, you have an opportunity to attend these live classes, attend these classes, attend the crash course, boost your score. Never be satisfied or be happy. There is always a room for improvement. Keep that in mind. All right? Great. Thank you for all the love from all the parts of the country, guys. So that's the answer. And I hope you guys have understood how to solve this. Okay. Niranjan, there is a book called as Pathfinder, Niranjan Kumar. So you can start solving that. Okay. Who am I? There is no tricks for semiconductors, bacha. You just need to solve the questions from 0 to hero plus the rank booster I conducted just few days back. Just do those things and trust me, you will be more than good. And obviously you need to do NCRT as well. Well, Risti, I'm right now in Bangalore. Come on, my warriors, figure this out. There is a soap bubble of radius r charged to a potential V. Now if the radius is increased n times, then what's the new potential on the bubble going to be? Come on, my warriors, start figuring out. Yep. Namrata, don't worry, bacha. Please attend my Pathfinder series. Right now, I have just taken a break from the Pathfinder series because we are concentrating on 2021 batch, because understand they need our help right now. They need all our support because their exams are next week. Meanwhile, please watch all the replays of my chapters from the Pathfinder series. Electrostatics, Gauss law, current, electricity. Trust me, you will improve. I've kept the level easy to difficult. It starts from basics, concepts are taught, then applying those concepts in problems, then advanced level problems, quizzes, everything are there. Just watch that. Okay, come on, my warriors, think about it. Thank you, Pavitra, so much. All right, C, D, people are confused. Satyajit and others, let's focus on the session. Probably I'll answer all your doubts, etc. Maybe a little bit later on. Whenever I get time, I'll try to answer, but now let's focus on the session. Guys, you guys are wrong. Many of you are wrong. Okay, some of you said C, they were correct. Some of you are saying D, some of you said A also, B also. My God, no. It's very simple. When you have a drop and it is charged, Okay, it is charged. So understand, the potential is given by K, Q by R. That's the value of the potential. Now, when you increase the radius, that means you expand it, the charge on it is constant because there is no way to escape. Where will the charge go? It's just expanding it. The charges will get distributed. They will get redistributed. Okay, they will just redistribute themselves. Now the only thing changing is R, guys. So if R has increased n times, then 1 by R, remember voltage is proportional to 1 by R. So hence this voltage will increase 1 by n times. If the denominator increases n times, obviously voltage should increase 1 by n times. So if the earlier voltage was V, the new voltage will be V by n. How can you get plus 5, man? You cannot get. Yeah. Nishant, why are you sad, man? I'm responding to you. If you just post the answers, but I don't know what doubt you have. If you have something which you want to ask, probably if it is related, I'll answer. But if it is not related right now, I will answer it later on. You can post all your doubts in the comment section after the video ends. All right? Very good. So I hope you guys understood it. Hello, Panay Mayam. Okay, I hope I got that name correct. Nice names you guys have. I'm pretty sure, yeah, I will get to know a lot of new names, teaching all you guys out there. All right, nice names you guys have. Hello, let's get going. Gopi Krishna, we are going to conduct the formula revision in the next 1 or 2 days. All right, don't worry. Very good. Come on, figure this question out. For the isolated charged conductor shown in the figure, the potential at points A, B, C and D are VA, VB, VC, VD respectively. Then which of the following option is correct? Think about it. Come on. Figure this out. Come on, Niranjan. Come on, Master Blaster. Come on, Satvik. Hello, Pooja. Namaste. Welcome. Does this session include advanced problems? Shyam, this is for JEE Mains and BitSat. So they will be of JEE Mains and BitSat level only. Come on. Yes, Papi Reddy, you should be. Wow, Papi Reddy has a very keen sense of observation. Very good. Come on, my warriors. D for sure. Very good. The correct answer is, oops. I'll come to that. I'll show you the answer, but there is a slightly modified question. We'll discuss both the answers together. So, same diagram, but the question is, what are the fields at all these points? Which point has more field, which point has less field? I just changed the question a little bit. Astro saying B. Come on, my warriors, figure this out. The earlier question was related to potential. Now this question is related to field A, B, C, D. What's the best way to compare these fields? Figure this out. We'll discuss both of them together. Yes, Nitya Priya, even if you are a NEET student, you can watch all the JEE Mains lectures or BitSat lectures. So in general, advice to all the NEET students, if you are a NEET aspirant, you can watch the JEE Mains classes, not the advanced classes. Although the JEE Mains level is obviously slightly higher sometimes as compared to NEET, but for the most of the part, 60 to 70% is very much similar. There might be 20%, 30% of the questions which are little bit more conceptual, little bit more in depth as compared to NEET. Okay, I know Yalini, you are NEET, but don't worry Yalini, because you are preparing via JEE class, you are going to be much better, as compared to your other teammates or classmates who are probably just preparing via NEET. Although, yeah, it's the right way to just study NEET, but I'm pretty sure whatever extra you are learning is not going to go waste, guarantee. Okay, B. Well, let's see the correct answers. The correct answer for the first one is D. All the potentials are equal. Now, this is a standard rule. You should know this. For a conductor, all points are at same potential. Doesn't matter how the shape is, even if there is a cavity. A lot of people think, sir, if there is a cavity, sir, then there will be a problem. Even if you connect it with a wire to another conductor and that conductor also has a cavity, doesn't matter. it really doesn't matter. This point, 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 all of them are going to be at the same potential. That's something which you should remember. That's for potential. So that's why the answer was D. But for field, there is another rule which you should, oops, one second. This was the next question. Let me just go behind. Please let my hand work. Magic, please work. Oh, it works. Finally, 3 times. That's the rule. Okay. So for a conductor and field, if you want to find the relation goes something like this. So this is the field, right? There will be something called as the radius of curvature. The radius of curvature. This field is always inversely proportional to the radius of curvature. Yeah, keep this in mind. And yes, that was the field outside, and inside the conductor, the field is always 0. So if this is the inside part, okay, the inside part, the field is always 0. Outside, it is always proportional to 1 by r, inversely proportional to the radius, and this field is also proportional to sigma. The sigma, understand, this is the charge, surface charge density. Okay, so remember this rule, very, very useful rule. So now, which is more sharp will have more field. That's the meaning. Which is more blunt, because R will be more if it is blunt. Okay, that's when the field will reduce. The sharper the surface, R is less, 1 by R will be more, E will be more. So you can see D is the sharpest point. So that's why D is more. Well, A and B, this point is inside. So if it is inside, the field is 0. Yes, that's correct then. And ED, EA and EC. I was wondering whether B was on the surface. Okay, so that word mentioned over there is inside, so it's fine. Okay. And ED is the highest because it's the sharpest point out here. And A and C, if you compare, C is on a blunt surface. You can see that. The surface is radius of curvature. This radius is very large, so it's very blunt, and hence that's the reason why the field is very less. A has some decent amount of radius of curvature, so the field is there, but it's not as sharp as point D. Hence option C is correct. Yep. Oh no, Akshay, who told you it is 1 by r square? A lot of people get this wrong. Wrong. Somebody is telling, sir, electric field is proportional to 1 by r square. Well, understand guys, well, here is the thing. You should know that sigma is inversely proportional to 1 by r. That's all. Just remember that. It is inversely proportional to r, not 1 by r square. Be careful. Okay. Chalo, let's get going to the next one coming up on your screen. And Akshay, I was keeping sigma as constant. I'm talking in terms of sigma, not in terms of charge. So it depends on what you keep as constant. XYZ, welcome. Okay, the correct answer is actually C. Very good. A lot of you got +4. Excellente, my warriors. This term over here, is nothing but flux in a closed surface. Flux in a closed surface. And the RHS is always Q in by epsilon naught. So if the total flux of the surface is 0, then this is true. Okay. And E is 0 on the surface, E is perpendicular, flux is going out of the surface. None of them make sense. It just means probably you have a surface. Let's say this is our surface. Maybe there is a positive charge here, negative charge here, negative charge here, and maybe a positive charge. Like you can see, the total enclosed charge is 0. But there are field lines going out. Alright, you can see field lines are going out. Field lines are also coming in. So what it tells you is that the total number of lines which are going out and the total number of lines which are going in, this out and in are equal. That's why the net flux, the total flux which is out plus that in, will be 0. out will be, let's say, positive, in will be, let's say, negative. So they will add up to become 0, that's all. But on the surface, field is there. Understand, field is not 0. Field might be there. You can see that on that surface. So the field on the surface is 0. This is wrong. Is perpendicular? It may be. It might make some angle. Some places it could be perpendicular. Some places it could make any kind of angle. So this is also wrong. And the flux is only going out. Wrong. It can go out as well as in. You can see that. It can go out as well as in. That's the reason why option C is correct. Yep. Okay. Thank you, Sire, for all the love. Alright, let's get going to the next question coming up on your screen. So these kind of questions are very common in JEE Mains. Find out the value of the flux inside this cube which is placed in a non-uniform field where the field value is E naught x I cap. E naught x I cap. The field is in the x direction and it changes with x. Renovator, you can join my micro courses. My long-term batch is the topper batch. So if you perform well in your regular tests, you can come into the topper batch. That's how it works. Okay, but my micro courses are available for free. You're attending this class. That means you're going to improve because you're going to realize something which you wouldn't know before this. Let's do this. So the field lines are parallel to the x-axis. That's very obvious. So the field will come like this and it will come out from here. Okay. Now please help me understand, out of the top, bottom, left, right, front and back. Okay, front, back, left, right, top, bottom. Which faces do you think the flux will have some contribution? Where do you think the flux will actually cut through the surfaces? Out of all these 6 ones, which are those ones? 1, 2, all. You let me know in the chat box. What do you think it is? Thank you, user V. Very good, Lavanya. Very good, Shruti. Very good, Devashri. Oh, Ruchita, no, that's not correct. Akshaya, think more. Yes, left. No, Vishwa, it's not all the areas. It's only left and right, because this is the area through which the flux will pierce in, and this is the area through which the flux will pierce out. So these are the only 2 areas. The top and bottom, it will just graze through it, or even the front and the back. It is not going to pierce through it. See, if it pierces, it should look like this. It's not going to pierce through it. It's just going to graze. It's not contributing anything. So this is gone, this is gone, this is gone, this is gone. Only left and right. That's one thing. Okay, now let's look at the side view and think about it. So this is my cube. Okay, this is my cube here. Okay, and this is my x-axis like this, and there is some field over here, and there is some different field over here because it is non-uniform, of course. So think this way, guys. This point is from the origin at a distance of L, I guess. Yep. Or whatever that is. Yep. Okay, so this is at a distance of L. Okay, so this is at a distance of L, and this is at a distance of L plus A. You can check this out. This is the left side. This is the right side of that cube. Everybody able to visualize? I'm seeing it from here. I'm seeing the front view. This is the face which will be seen, okay? But I'm not showing it. I'm just showing the left and the right faces and the flux cutting through it. Is everybody clear about this? Let me know in the chat box if you guys are clear by putting up a yo or a thumbs up. Okay, now figure this bit out. What do you think is the field? What do you think is the field over here? Look at this function, E naught x. So if you give me the value of x, I can tell you the field. So the field over here is E naught into L. The field over there is just E naught into L. Cool? What is the field here? Look at the value of x. It's L plus A. So it is going to be E naught. Substitute the value of x as L plus A. Okay, so that's the field. Now comes the flux. The net flux, remember, the net flux is field into area at every point. Field into area. So do you see what's the field over here on the left surface? Well, it's E naught into L. What's the area of this left side? This area, guys, I'm talking about this area. What's the area of this? Think about it. It's A square, right? Into A square. Now here is the thing. Understand, this is coming inside. Yes, this is coming inside, and in is always negative, and this is going outside, so outside is positive. Going out is positive, coming in is negative. Remember, negative charges will pull in the field lines. Negative charge, negative, hence inside is negative. Positive charges will give flux outside, so it's positive. So I should put a minus sign here. Plus, if you miss that, you're going to get a wrong answer. Plus, okay, what is that? Field is nothing but E naught into L plus A into area. What is this area? Obviously, it's again going to be A square. Yeah, it's going to be A square. Cool. So you can see this is nothing but minus E naught L A square plus E naught L A square plus E naught A into A square. You can see both these terms cancel, and I'll be left with E naught into A cube. And is that answer going to be B? Yep, it's going to be B. Some of you said it now. Yes, Ravanan, I took it as negative, don't worry. So, the logic behind this question is that since there is non-uniform field, you need to find the field at different surfaces and then try to find the flux, and there are some phases where there is no contribution, especially the unshaded ones. The flux is only through the shaded ones. Now somebody also said, sir, there is no charge inside. How are you saying there is flux? Guys, understand, the question says there is a field which is non-uniform. They have not mentioned anything about the charges. Maybe this non-uniformity has come as a result of charges inside and outside. How do you know that? Nothing has been mentioned about the charges. So it just says that it is a non-uniform field. How did it become non-uniform? There is no mention of that. So because there is a charge inside, in fact, that's the reason why this flux is there. I hope that makes sense. In fact, you can find how much charge is there inside. How do you find the charge inside? Just equate it to Q in by epsilon naught. So epsilon naught goes here. So E naught epsilon naught A cube is the total charge present inside. That's the reason why the field is non-uniform, and you will get the answer. Is that clear? These kind of questions are very common in JEE Mains, and you should know this even in BitSat, and even for NEET. It will be a little bit difficult one though. Okay, cool. Let's get going. Aman saying how I did not understand about the electric field. Well, see, understand this. At this surface, the value of x is L. So the field on that surface, what will be the field? Use this function where x is basically L. So that's how I got field is E naught into L, and the flux is always field multiplied by area if it is assuming perpendicular. So that's why I got it as E naught into L into A square, but since it was going inside, that's why it was negative. That's all. That's how I got it. Okay, I hope you got it. Great. Chalo. Beautiful question, guys, and let's get going to the next one. And guys, if you're enjoying this session, I hope you have smashed that like button down there in case you have forgotten to do so. And if you're a new student to this English channel, please hit the subscribe button so that you do not miss any of our further sessions of Rank Booster series, Sure Shot series, the Pathfinder, then the Nurture series. Recommend this channel to all your lovely juniors out there. Very good. Thank you, Cam. Yes, Tarun, the crash course will now be extended till 4th attempt. Because these guys are playing games. They are playing. It's like Big Boss House or Roadies or Splitsvilla. I don't know. It's more exciting than that. So that you should follow their Twitter pages. It's amazing. Every now and then there is a new announcement. And that okay, now the date is going to be this. Who is going to get voted out? Is this going to get cancelled? Is this going to get postponed? अगले season में कौन आने वाला है? Who is the new entry into the new season? Who is going to exit? I don't know. Is the syllabus going to get cancelled? Is boards is only going to get cancelled? Boards marks are not going to be counted. What is the eligibility criteria? So much of confusion. I mean, like really, I hats off to you guys. Huh? You guys, when you grow up now, you'll have lots of stories to tell to all your juniors that we are from that Corona batch and we had every possible scenario planned in our head, and we had amazing teachers who gave us strategy for every kind of scenario. Exam is happening tomorrow, strategy session, how to crack JEE exam in 1 day. Exam is postponed for 2 months, strategy session for how to crack exam in 2 months. Everything we had all planned. Don't worry. Rank booster series for 2 days, rank booster series for 100 days, 2021 batch, studying with 2022 batch, studying with 2023 batch, all the same portions. Everybody is studying. You are studying the same thing as 12th standard, most of you. Some of you have started the preparation right now. And it's going on. 12th standard student is also attending rank booster. Rank booster students are also attending 12th standard lectures. And some of the late students who woke up very late in April or March, they started attending 11th standard classes. Sir, I didn't study 11th standard, sir. Good. Look at this. All 3 batches studying together. Beautiful harmony. There's no difference of juniors and seniors. Amazing. This would be an amazing batch that you guys will remember. Okay. So let's see the correct answer for this. Well, if you have a dipole negative positive and you are at some distance and this is a charge Q, what we have is the field. The field is some constant which you should not worry about. It's actually K, P. Okay, K is 1/4 pi epsilon naught, P is dipole moment, and you have X cube, if you remember it correctly. X is there. So what happens is, when this X becomes 2 times, this X cube becomes 8 times. But this is in the denominator, so this field will reduce by 8 times. Now the field reduces 8 times, the force is Q multiplied by the field. So if this field goes 8 times low, this force will also go 8 times less, and hence the correct answer is C. Very good, Harish. I'm pretty sure you'll have a lot of like-minded people out there. Thank you, Pavitra. Very good, Muntazar Alam. Alright, let's get going to the next one. Sir, for last minute revision, will these concept and test video help us? Everything, Akshita. Whatever we are doing, everything is helpful. Nothing is useless. See, if there was something useless, I would not be coming and wasting my 3+ hours over here. Whatever we do is useful for you guys. Trust me. Yo, come on. Figure this out. Question on capacitors. Let's see how many of you can get it. Yo, Shubhankar, like button ko thoko. Thoko tali. A parallel air-filled capacitor as shown in figure has a capacitance of 2 microfarad. Now half of it is filled with a dielectric, half of it is remaining as it is. What's the new capacitance? Earlier the capacitance was 2, what's the new one? Yes, Aman, the session started at 9 AM. Tarun, if the third wave comes, I don't think they will prepone it. Exams can never be preponed, understand that. I mean, any sane institution or sane person can never prepone an exam. Okay, you are telling that the exam will be after 1 month and suddenly tell, no, the exam is going to be tomorrow. That's not what is going to happen. You better pray that the third wave doesn't come before your 4th attempt, because if it comes, then again it will get postponed. So you better pray for that. Yeah, third wave is postponed. Yes, that's correct way of telling that, Ruchita. Let's postpone the third wave. Okay, C and D. A lot of you are confused. Well, I'll tell you what. When it is completely filled with air, the capacitance is epsilon naught A divided by D. Standard formula for a parallel plate capacitor. Now the capacitance is already given to be 2 microfarad. It's given over here. You can see that. Okay. So I'll just put this 2 is equal to epsilon naught A by D. Just leave it aside. Now let's focus on this one. Do you see this system is actually 2 capacitors in series where one of them is filled with a K, another one is just air. So they are basically capacitors in series, but the new distance is d by 2, area of them is still A only. So the upper half is this, the lower half is this. So 2 capacitors. Now what happens in series? Well, we all know the 1 upon C effective is 1 upon C1, or basically that upper capacitor plus 1 upon C2. So remember, for capacitors the formulas are exactly opposite to that of resistors. Keep that in mind. Okay, let's start doing this. So 1 by C1. C1 is epsilon naught A by D, but D is D by 2. Okay, so D by 2. Okay, that's one thing. Plus, next term, epsilon naught for this guy. The epsilon naught value should be multiplied by K because there is a dielectric. So do not forget to multiply it by K. Is the dielectric constant given? Yep, it is given. K is 3. It's given. So into 3, okay, into A by D by 2. Okay, so just put it over here. Now let's see what happens. Okay. So 1 by C effective is equal to, well, epsilon naught A by D. Epsilon naught A by D is actually 2. So how about just substituting that as 2 and that 2 remains plus 1 by epsilon naught A by D. Look at this, epsilon naught A by D. Same thing, epsilon naught A by D is nothing but 2. So just replace it with 2 and there is 3 and 2 also over here. So this will be 1 by 2 into 2 is 4 and 1 plus 1 by 3, which is 1 by 4. 1 plus 1 by 3 is 4 by 3. So that's going to be 1 by 3. So this is 1 by C effective. So C effective will be 3. And is that there in the options? Yes, it is there. A lot of you are saying B, some of you are saying C. All those who said C are correct. All those who said B is wrong. Yup, beautiful. Excellent. Tarun, still many people will make mistakes. Just because you get it correct does not mean everyone else will get it. You should be happy that you got it. You should be happy that you are going to be much better than all those people who will not get this question. So yeah, good if you guys got it. So it's going to take some time to actually sit and calculate this, but apart from that, it's fine. Okay, let's get going to the next one. Beautiful question. The circuit shown in the figure has capacitors, all of them equal to 4. All of them have 4 microfarad. This voltage is 5 volts. What's the voltage across this capacitor A and B? Let's see how many of you are going to calculate this really fast. Okay, come on. Figure this out. All of them are equal capacitors. Figure this out. Sir, I write it in fraction. That's why I was getting option A. Oh my God. No, who am I? What you did was you forgot to take the inverse of it. No, Anirudh. In series, what will happen? The area will be the same. There are parallel plates. Think of it like that. So it's a capacitor. Half of it is dielectric, half of it is air. So obviously this area will be same. So what changes is the distance. If you divide it like this, then the area will change, distance will be same. So it depends how you are partitioning it. So visualize it. Okay? Okay, my God, this should not have been done. Okay, let's go to the, okay, I think by mistake my hand touched the board and I'm guessing the answer was displayed, but whatever. Yep. Only the distance will change. Yes, Harish. Okay. Let's see. Wow, the same question was there. It doesn't matter. Okay. So what you need to do, I'll tell you a very easy way to solve this. First of all, draw the equivalent circuit in a simpler way. First of all, these two are in series. Okay. These two are in series. So in series, what will happen? C1, C2 by C1 plus C2 will be the equivalent capacitance. So their equivalent will be 2 microfarad. Each one of them is 4. So 4 by 2, which is 2. Now these two are in parallel. So here is how it will look like. So this is one capacitor, this is another capacitor. This is together one capacitor, right? So I need to show it as one single capacitor. This is my battery, and there we go. This is 4 microfarad. What will this capacitance be? Well, simple. This 2 and this 4. So 2 into 4, all right, divided by 2 plus 4, guys. I hope this makes sense, what we have done. Okay, so this was 2 microfarad, this was 4 microfarad. Everybody understanding what we have done? Okay, 2 4s are 8, and yes, was it? Yeah, okay, cool. Just check this out once if every value is correct or wrong. Oh, my bad. 1 second. These two are in parallel, right? These two are in parallel. Hold on. This is a 2 microfarad and this is a 4 microfarad. They are in parallel. So hence, this will be nothing but 4 plus this 2, which will be 6. Okay, so this is 6 microfarad. Now, what we need to do, this is a 4 microfarad and this is a 6 microfarad in series. This is a 4 and 6 in series. And we know this, that for capacitors in series, remember, Q is same. That's the reason why the voltage is inversely proportional to capacitance. The voltage is inversely proportional to capacitance. I hope you remember that. So hence, I can write it as voltage across 6 upon voltage across 6 upon voltage across 4 will be 4 microfarad upon 6 microfarad. I hope this makes sense because capacitors are in series. Now, next thing what I'll do, I'll apply componendo. Let's just apply componendo and see things will be a little bit simpler. So this will become V6 plus V4 divided by V4 will be 4 plus 6 divided by 6. What is V6 plus V4? The voltage across this plus this will be this voltage. What is this voltage given to be? This voltage is given to be 5 volts. So hence what we are going to get is this is 5 divided by V4 is equal to 10 divided by 6. So hence what is the value of V4 going to be? So the value of V4 from this will be, there will be 2 over there, and that's it. Oh my bad. This is 2. Yes, this is 3. Yeah, this was 3 volts. Correct. Yeah, that's fine. Now what do we need to do? What do we need to do? Now we got V4. We need to find V6. Yes, we can find V6. How do we find V6? Because V4 is 3 and this is 5, we can find V6 as 5 volt minus 3 volt. So this will be basically 2 volt. Just check this out. This will be 2 volts. Yep, we can find this as 2 volts. Now once we got this as 2 volts, I know one thing. This voltage and this voltage will be equal. And the total will be equal to 2 volts. If the total is 2 volts and each voltage will be equal, why their voltages will be equal? Because the capacitances are equal. Hence, each one of them will be 1 volt. Does that make sense? Look at that. So we found out V4. V4 was 3 volt. If I know V4, I can find out this voltage. This voltage came out to be 2 volts. So the voltage across these 2 points is 2. This and this will have the same voltage drop. Hence, each one of them will have 1 volt. Yep, that's what it would be. Yep. So that's the answer. Let's just check it. Yep, 1 volt is the answer. Correct. Very good. Let's get going to the next one. So this was a question on series and parallel. You just need to go to the equivalent circuit and then go reverse. In fact, I have taught this method in Pathfinder that always go from you know, the complex circuit to a simple one, and again go back when you want to find the individual voltages. Chalo, let's do this next question. When the plates of a parallel capacitor of a capacitance 3 microfarad are connected by a wire of resistance R, the field between them drops to half the value in 6.9 microseconds. What's the value of the resistance? Come on, figure this out. Okay, come on. Which formula do we need to use? Well, the question is on field. The field between the plates of a capacitor, is there a formula for that? Yes, field is del V by del R, if you remember, del V by del X or del V by del R, magnitude wise. So can I say it is the voltage difference divided by the distance between the plates? Okay, now what is voltage? Voltage is nothing but Q is CV, V is Q by C. So charge by C is voltage, and that comes over here. But I know the value of capacitance. Well, the value of the capacitance is nothing but epsilon naught A by D, and that D will come here. This D and this D will cancel. Cool. So therefore, my field will become this value. I can write it like this. Capital Q, because this is the charge at any instant. So this small q is the charge at any instant. So that is capital Q into 1 minus e to the power minus t by RC. Think about it. Charge as a function of time for charging of a capacitor. So you are connecting a parallel plate capacitor to a wire resistance. Okay, what is the value after some time? That's the question, guys. So, but that is if it is getting charged. Now, as such, there is no battery in the question. Now, if there is no battery in the question, then you will not use this equation. In fact, I will go to e to the power minus t by RC. Remember, 1 minus e to the power minus t by RC is when there is a battery. And this is when there is no battery and it is getting discharged. So it is dropping. You can see it is dropping. That means there is no battery. It's continuously getting discharged. Now, this divided by epsilon naught into A. Now, don't you see, guys, this whole value over here is actually going to be the initial field. Why is it going to be the initial field? Because if you put t is equal to 0, e raised to 0 is 1. So the field will come out to be this. So this is going to be the initial field. I hope you guys get that. So half its initial value means whatever value was there at the start, the half of that. So this is the initial value. Please understand that, the initial field. So half of Q by epsilon naught A will be Q by A epsilon naught into e to the power minus t by RC. Now Q by A epsilon naught gets cancelled. I have half is equal to, instead of putting this on the top with a negative power, I will write it like this, e to the power t by RC. Therefore, e to the power t by RC is equal to 2. Therefore, convert it into logarithms. You will get log of 2 is equal to t by RC. Therefore, R is equal to t by ln 2 multiplied by C. Therefore, what is the value of time? Is it given? What is the value of time? Yes, 6.9. 6.9 into 10 to the power minus 6 divided by log 2 is 0.69 into what is the value of C? That's given to be 3 into 10 to the power minus 6. 10 to the power minus 6, 10 to the power minus 6 goes 0.69 and 6.9, that's going to be 10. And only 1 3 will remain. So 10 by 3, that would be ohm. Yeah, is 10 by 3 ohm there? Yes, that's option C, guys. That's how it is. How many of you loved this question? So what was the concept involved over here? More than concept, it is more about remembering those formulas. you have to think reverse. Field is delta V by delta R, voltage by distance. Voltage between the plates is V, distance between the plates is D. What is voltage? Q is CV, so voltage is Q by C. What is capacitance? Acha, capacitance is epsilon naught A by D. Okay, D got cancelled. Okay, then I got this. Now think, initial field will be when T is 0. E raised to 0 is 1. So this is the initial value. So half of the initial field is got after some time. So I just substituted E as half of the initial field. And then rest of it is pure maths and substitution. Yeah. So I hope, Reksha, now that confusion is gone. I just went through the problem like a complete recap. Here all the formulas are used. Q is CV, C is epsilon naught A by D, E is V by D, charge is a function of time, and then figuring out initial field is going to be this one. So this is the catch. A lot of people make a mistake here. See this, why T is equal to 0. What happens over here is that when you put T is equal to 0, field will come out to be epsilon naught, sorry, not epsilon naught, Q by A epsilon naught, because E raised to 0 is nothing but 1. So this is the initial field. So half of that is what you get. Okay. So this will be in the lengthy category. Probably you should do it at the end if you do not want to waste your time at the start. Okay, let's get going to the next question coming up on your screen. Yep, all in one question. Let's get going to the next one. So there are two rings. Now this is very beautiful question. Let's see. And they are both identical. They are thin. Radius is R. They are coaxial. One of them is Q1. Another of them is Q2. The question is, what is the work done in moving a charge from one center to the other center? Okay, let's see how to solve this. So there is a ring coaxial with another ring. This is Q1, this is Q2. What is the separation between them? The separation, yes, it's R. The distance between them is R, and the radius of each ring, that's also, I think, given to be R. Let's just check that out. Of each of radius R, yes. Now you want to take the charge from here, this is initial position, to a final position over here. Okay, from the center of one ring to the other ring. So the question is what you are going to do. Well, yes, Krishna, I'm teacher by choice. Okay, are you guys ready to start solving these questions? Are you guys solving this on your own as well? Please let me know in the chat box if you are doing so. Beautiful question. Have you got any answer? Please let me know, and you can type it out in the chat box if you guys have figured out this answer. First of all, when the charge is here, okay, initially, what would be the initial potential? Let's say the charge is here. What's the initial potential? Not energy, potential. So the potential will be, remember the formula for potential due to a ring. Well, if you remember that formula only, then you will get it, or else you will probably make a mistake. There will be potential because of this ring as well as this ring. Lot of you are going to say, sir, it is just K, Q by R. Now, even this ring is charged. That ring will also give a potential at the center. Please keep that in mind. See if you guys are able to see that. Yeah? Are you guys able to see that? Think about it. Be very careful about it. Now, I hope you also see this charge or this point is equidistant from all the points on the ring, and that distance, think about it, this distance. If this is R, this is R, this is root 2R. So the potential due to all the charges on the ring will be K Q2 divided by root 2R. That's the potential at the center of that particular ring. Similarly, final voltage at this point will be potential due to all the charges on this ring, which is K Q2 divided by R, plus all the charges here will also give rise to potential. And what is that distance? That's also root 2R, because this is R, that's the hypotenuse. Okay, so that's also going to be K Q1 by root 2R. Great. Now the next step is, if I want to find the initial energy that will be charge into potential. Charge into voltage gives you energy. So just multiply this with a charge. I think the charge taken is small q. Okay, I think yes, the charge taken is small q. So just multiply with q. Same thing over here. The final energy will be charge into voltage. So this thing multiplied by q. And the last step will be the work done will be final minus initial energy. So you're changing the energy. So whatever work you do goes in changing that electrical energy. So just substitute the values. That's it. So UF will be this value. So it will be K Q by R is constant, and there you have, all right, Q2 plus Q1 by root 2. That's one term. Okay, same thing again over here. K Q by R will be there, plus K Q by R will be there. This will be minus because you have a minus here, and you will have 1 plus 1 by root 2, but this one will be actually Q1 and this one over here will be Q2. Yeah, that's what you will get. Just check this out. So they will not cancel, by the way. Yep, this was Q2. Yep, this was Q2 plus Q1 by root 2. Yep, this was Q1 plus Q2 by root 2. I think everything should be fine now. Now you subtract both of them. Yes, you subtract both of them and see what do you get as the answer. So you will see K, this was actually small q guys, yeah, K small q divided by R. You will have Q1 by root 2 minus Q1, and here you will have Q2 by root 2 with a negative sign and plus Q2. This is what you're going to get. Now solve this, rationalize it and see which of the answers matches. So root 2 minus 1 will be there here also and over there also. So yeah, there should be root 2 minus 1. I think root 2 minus 1 is there here and root 2 should be there in the denominator. So only B option will be correct. Check if B option is correct. Yeah. Yes, B is correct. Very good. Determine the current through the battery, 12 volt battery. Internal resistance 0.5 ohm, infinite network of resistors. Let's see how many of you can get this. Each resistance is 1 ohm. Each resistance is 1 ohm. Hereafter you will not leave it. Yes, Ravi Kumar, you can even join for half of the class. It's okay. You can watch the remaining class live, and whatever you missed, you can watch the replay later on. Okay, don't worry about it. Come on, think about it. How are you going to solve this question? There are infinite resistors, so there is a standard way of solving it. What you need to do is, whichever part or pattern is repeating, that since this is that pattern which is repeating, you add one more resistance. So how are you going to add that resistance? Just add it wherever you want to. Okay, you will not have any problem. So let's say this entire equivalent resistance is X. You add that repeating pattern. What is that repeating pattern? This is that repeating pattern like this between these 2 points. This is 1, this is 1, this is 1. The resistance between these 2 points will still be X. This entire thing, you just add one more pattern, nothing will change. It will still be X. Nothing has changed. Now, understand these two resistors are in parallel. So, what will be their equivalent? Figure this out. Their equivalent will be 1 into X upon 1 plus X. This is 1 ohm and this is 1 ohm over here. And the equivalent between them is still going to be X. I hope this is clear. Can we do this with sigma? No, don't do this with sigma and all. This will be easier like this. Okay, so these two are in parallel. So I found out the equivalent. Now this and this are in series. So the equivalent resistance, okay, will be 1 plus 1 plus X by 1 plus X. This whole thing will be again X. I hope this is clear, because the whole thing should have the same equivalent, because this infinite resistance plus one more pattern should not make any difference. Now what do you need to do? Okay, so this is 2 plus x by 1 plus x is equal to x. Okay, just take the LCM and make the denominators common. You will see 2 into 1 plus x is equal to x into 1 plus x. Now just solve this. You will have 2 plus 2x plus x is equal to x plus x square. Now this x and this x will get cancelled, and you will have x square minus 2x minus 2 is equal to 0. Okay, you will have this. Once you have this, solve this quadratic equation. Always remember, in infinite problem you will always get a quadratic equation. So what is the value of x that you will get? You will get minus b, which is 2, plus or minus b square, which is 4, minus 4 into a into c, which is minus 2. Okay, so that's what you're going to get, divided by 2. So you'll get 2 plus or minus divided by 2. 4 2s are 8, 8 plus 4 is 12. Root of 12 is nothing but 2 root 3. So I will get 1 plus or minus root 3, but negative value is not acceptable. So the value of x, which is valid, will be 1 plus root 3. So this is the equivalent resistance. Now once you get this, think this entire circuit, okay, this entire circuit can be replaced by one single resistance as 1 plus root 3 ohm, and that is in series with this 0.5 ohm. So the current will be the voltage, which is 12 volts, divided by x plus that internal resistance, which is 12 divided by 1 plus root 3 plus 0.5. Now do the math. What do you get? Root 3 is 1.732. This is nothing but 12 divided by 1.73 plus 1.5. Now this will be slightly more than 3, the denominator. So the answer should be slightly less than 4. So hence it should be C. Check this out. Very good. Okay, very good. So the whole idea was, whichever pattern gets repeated, just add it to infinity, it will not make any difference, and you have to get a quadratic equation. So once I got that equivalent resistance, since the question asked us to figure out the current, so just show this entire circuit as one single resistance in series with this 0.5 ohm. So voltage by total resistance is going to give you the current. That's all I have done. Okay, I think that should be the correct answer, 3.7. Okay, let's get going to the next question. Just 1 second, guys. Is there a problem on catalysis? Just 1 second. Okay, cool. Hello, Natasha. Hello, Vaishnavi. Welcome aboard. Now, let's get going to this question, guys. Start solving. If you have started seeing this question on your screen, find the value of the current in the network shown over here. Come on, figure this out. Well, a lot of questions, guys, and then we are also going to have a 15-minute break after some time. More 5-6 questions, and then we are going to have a break. I hope you guys have not died out. I hope you guys are not low on energy. I hope you guys are still full of josh. Okay, don't give up, because you have to sit continuously for 3 hours in the examination. So guys, come on. Yep, please gear up. How many of you have figured out the answer? Some of you are saying 1 ampere. Some of you are saying D, which is 1 ampere. Let's see whether you are correct. Very good, Ravi Kumar. All right, let's see. First of all, this is a disguised circuit. The circuit looks complicated, but actually it's very simple if you mark the potentials. Let's say this is point A, let's say this is point B, let's say this will be also point B because this is a wire. and if this is B and this is, let's say, C. Okay, now what we can do is we can show that there is a battery, okay, of 6 volt. This is our point B and this is our point C. From this point B, there is one resistor which is 2 ohm, and this resistor 6 ohm, both are in parallel because the voltage drop across both of them is the same. BB, AA, 2 and 6 have the same voltage drop. So that means I should show 2 resistors in parallel. One is 2 ohm, one is 6 ohm. And this point A is connected to 1.5 ohm via this point C to the battery. Okay. So there is one more resistor connected to point C. This is 1.5 ohm. Last thing, B and C also have one more resistor in parallel, which is 3 ohm. So you can see I can draw one more resistor like this, and that is nothing but 3 ohm. Now this looks like a series parallel circuit. Got it? Yep. So all you need to do now is figure out what is their equivalent. First of all, figure this out. 6 and 2. So that will be 6 into 2 divided by 6 plus 2. 6 2s are 12. And this will be nothing but 8. So 12 divided by 8 divided by 4. So this will be 3 and this will be 2. Now this 3 by 2 and this 1.5. These both are in series. So the equivalent of these two should be nothing but 1.5 plus 1.5, which is nothing but 3 ohm. Now this 3 ohm and this 3 ohm are in parallel. I hope this is clear. Everybody understanding this till this point? Do let me know. Yeah. So finally, what are you going to get? The equivalent resistance. 3 and 3 are in parallel. The equivalent resistance will be just 1.5 ohm, which is connected to this battery of 6 volt, because this 3 and this 3 are in parallel. So the question was, what is the current, right? So the question will be, which was current, so that's voltage divided by that resistance. So what's the final answer? What do you get? Yeah, 4 amperes. Just check this out. Very good. A lot of you said A. Very good. You should dance with joy, because this is nothing but a simple series and parallel circuit, nothing apart from that. Okay, cool. But you should get to know which one is in series, which one is in parallel. Yeah, the answer is 4 amperes. Let's see whether you can solve this question coming up on your screen. So there are two EMFs. One is 1.5 volt, another one is 2 volt. Internal resistance is 1, the other one is 1.5. External resistance is 2.5. Question is, find the potential difference between A and B. Now, a lot of you are going to make a mistake over here. The question is, find the potential difference between points A and B. So VA minus VB. Actually, this should be specified. This is the question. What is VA minus VB? First of all, figure out how is the current going to flow, because that's going to make a hell lot of difference. Is it going to flow clockwise or is it going to flow anti-clockwise? Let me know in the chat box. Thank you, Siva. Come on. How is the current going to flow? Figure this out. Is it going to flow clockwise or is it going to flow anti-clockwise? Which voltage is more, 2 or 1.5? Obviously 2. And how is it pointed? Towards the left side. So more voltage this way. So obviously the current is going to flow like this. The current is going to flow like this. And this current will be total voltage divided by total resistance. What's the total voltage? That's going to be 2 minus. Why minus? Because it's opposite. Please observe those batteries carefully, else you will get a wrong answer. Minus 1.5 divided by total resistance. One is 1 ohm, the other one is 1.5, and this one is 2.5. So this is nothing but 0.5 divided by 1.5 plus 2.5, that's 4 and 5. Yeah, so that's going to be, just check this out, 0.1 ampere. The current is going to be 0.1 ampere. Now, Once you get the current, be careful. The question is, what's the voltage between A and B? Understand, it's unsaid rule that if the battery has internal resistance, it's not generally shown, but you can show it like an external resistance, which is right now 1 ohm. Now use Kirchhoff's voltage law. Use KVL law, but incomplete law, where I have taught you how to go from one point to the other. So let's say I start from VA, or let's say I start from VB. Okay, use the KVL incomplete law. So voltage at point B, and then I encounter different devices on the way. The first one is this resistance. What's the voltage drop across this 1 ohm? It will be IR. What is I? What is I? It is 0.1 into resistance. What is it? It's 1. Why is this minus sign? Because I'm going from point B to point A in the direction of current. Remember, in the direction of current, across a resistor, voltage will drop. That's why the minus sign. For this battery, again I'm going from plus to minus. Plus to minus, again the voltage will drop, and that battery is 1.5 volt. So I should put minus 1.5, and eventually I reach point A. Now take this guy on the other side. So you have minus 0.1 minus 1.5 is equal to VA minus VB. Therefore, this will be minus 1.6 volts is VAB. That's the answer, which is option C. Yeah. So that's why I said we should be given which one is asked, VA minus VB or VB minus VA. Now that information was missing. So I am telling you the question actually meant VA minus VB. If the question said VB minus VA, then the answer would be plus 1.6 volt. And remember, you need not always go from B to A. You can go from A to B. You will still land with the same answer. That's how you need to do this. Okay, let's get going to the next question coming up on your screen. Okay, now a lot of people get scared the moment they see potentiometers. So don't get scared. Number one, this is not that difficult question. You can see there is a meter bridge kind of an arrangement. There is resistance here and here. There is a galvanometer. This is a wire. This is an external battery. Now the principle behind this working is that, you know, this is actually like a Wheatstone's bridge. This is like a Wheatstone's bridge. This is R1, this is R2. This much part has some resistance. Let's say I call it R3. This much part has some resistance. Let's say I call it R4. This is this potentiometer wire. If R1 by R2 is R3 by R4, then there will be no current which will flow in the galvanometer. It is balanced. That's when you get something called as the null point. That's when you get something called as the null point. It's a Wheatstone's bridge. Now the logic behind it is, when it is balanced, okay, when it is balanced, here is how the formula works. R1 by R2 will be this resistance upon this resistance. So resistance of A to this point, let's say D, upon resistance of D to C. Resistance of D to C. Now, since resistance is proportional to length, therefore, think what will you get? It will, this resistance by this resistance will be this length by this length. So that length will be small l divided by this length, which will be total length minus that small length. This is the equation that you get, which you need to use. Okay, the total length minus the smaller length. This is the formula. Now this L is usually 100 centimeters, but if something else is also given, you can substitute that capital L as 120, 110, whatever is given to you. So this is your starting equation. Now let's start with the actual problem. First time when you are using R1 and R2, the null point is 40 centimeters. Okay, L1 is 40 centimeters. So I'll just write R1 by R2 is equal to 40 divided by 100 minus 40, obviously it's 60. Okay, if you do not understand it, no problem, I'll just put it over here. 100 minus 40. So this is 40 by 60, which is 4 by 6, which is nothing but 2 by 3. Great, I'll just put it aside. Next time, when 12 ohm resistance is connected in parallel with this resistor, so when you connect a 12 ohm resistance in parallel, the new length is 60 centimeters. So this time it will be R1 by R2 multiplied by 12 divided by R2 plus 12, because they are in parallel, will be, null point is at 60 centimeters. So 60 divided by 100 minus 60. 100 minus 60? 40. 60 by 40? 6 by 4? Okay, 3 by 2. Now just rearrange this. It's just a matter of rearranging all of this. Let's see, what do we get? So R1 into R2 plus R12 divided by R2 into 12 is equal to 3 by 2. Next step. What is the next step? Okay, I'll just remove this since I don't need this anymore. R1 by R2 is 2 by 3. Look at that, R1 by R2 is 2 by 3. Just use this fact. It is nothing but 2 by 3. So this will be 2 by 3 into, sorry, this was 12 ohm. Yeah. So this will be into R2 plus 12 divided by 12 is equal to 3 by 2. Now do you see, this is just one single equation which you need to solve. You just need to solve. Yes, correct. Substitute R1 by R2. Yep. So therefore, what do we get? Look at this. This will cancel. This will become 6. And yeah, take it on the other side. So R2 plus 12 into 2 is equal to 3 into 3 into 6. So this will become 2R2 plus 24 is 9 into 6. Yeah. So we have 54. So 2R2 is equal to 30. 54 minus 24 is 30. So R2 will be 15 ohms. There you have it, 15 ohms. Naturally, you will get R1 also. Yeah, very good. That's how you need to do it. So, quite a lot of maths, but you need to be patient enough to solve the question without doing any kind of mistakes. If you do calculation mistakes, you will probably get some other answer, or you will not get any of them only. So, the concept over here was Wheatstone's bridge, and this resistance by this resistance is this length by this length. Rest all was basic multiplication, division and algebra. So that's the answer. Let's get going to the next question coming up on your screen. Yep, only option 1 will satisfy that equation. Oh, is that? Oh, you didn't even solve the rest of the things. That's a smart move, Preksha. I mean, R1 by R2, I think we just got it as 3 by 2 or 2 by 3. So just check that out. Very good. You can do that in the examination if it's objective. If it's in subjective, or if the options are not getting eliminated, then we cannot help it other than solving it. Yep. So each resistance of the network shown in the figure is equal to R. Was the equivalent between A and B? Okay, looks like people have bahated this or what, Akshita? Okay. Come on, my warriors, figure this out. Let's see. Whenever these kind of questions come, use symmetry. Is there a line of symmetry? Just think about it. Yes, there are lots of lines of symmetry you can have, but the one which I would be interested in is this. You should first check both the points across which you want to find the equivalent. These are the 2 points. Now, just imagine a line between these 2 points and draw a perpendicular bisector. Draw a perpendicular bisector. Now just check if there is some kind of symmetry across this perpendicular bisector. Is whatever there on the left side also there on the right side? Whatever is there on the left is also there on the right? Yes, it is. So you can see that on this line, okay, this is the line of symmetry, and whatever points are there, they will be at the same potential. This point, this point, this point. But there is no wire between them. So there is nothing that you can remove to start solving the problem. So what you need to do is that if you see a junction, see on a line of symmetry, if there are 2 points, you can disconnect the wire between them because both their voltages will be same. But if you do not have a wire, what you do, make a wire by splitting that junction. You will see there will be a junction, split it, and you will probably make it like this. So make that junction into two junctions and now remove the wire. That's the approach you need to use. So in this question, what you can do is, there is a junction here, split it and see what you get. You will get this resistor here, this one on the top, and this one here like this. You will have this resistor and this resistor like this resistance like this, the one below and the one here at an angle like that. Now split this. So you're going to draw a resistor here and draw a resistor here. That's it. This is the junction, and same thing over here, a resistor here and a resistor here. This is the junction. So this wire, understand, can be disconnected because it lies on the line of symmetry. All of them are at the same potential. Yes, Clay Tsunami, we have just used symmetry, nothing else. Yes, Aman, very good. You have already figured out the answer, looks like it. So now it's simple. These two are in series. R and R is 2R. These are in parallel. So 2R and R in parallel. So it will be 2R by 3. Very good. So even this should be, oops, sorry, not the entire thing. This one is 2R by 3. This one will also be 2R by 3. So this entire thing will be 2R by 3 plus R plus R. So check that out. That will be nothing but 2R. Okay, 1 by 3 plus 2. So that's going to make it 3 to the 6. And there we have it. Yeah, am I correct? Oh, sorry, I don't need that 2 anymore. So plus 1. Okay. So that will become 2R multiplied by 4 by 3, which is nothing but 8R by 3. So this branch and this branch all are 8 by 3. The middle branch, this middle branch, how much it is? It is 2R. Yes, this middle branch will be 2R. Is this clear, everybody? Please let me know by giving up a thumbs up if you understood till this point. So the first point was, we saw line of symmetry, which was the perpendicular bisector. All points on the line of symmetry, same potential. But there was nothing to disconnect. I saw a junction. So split that junction into as many parts required. All these points, same potential. Now it becomes a simple series parallel circuit. R and R, 2R. 2R and R parallel, 2R by 3. This is also 2R by 3. This 2R by 3, this R and this R, series. So just add them and see, do you get 8R by 3? Very good. Now, last step, you have to find the equivalent. So 1 by R equivalent, because this branch and this branch are in parallel. So what you need to do is 1 by 8R by 3 plus 1 by 8R by 3 plus, this is nothing but 2R. So first you can do this, 3 plus 3 plus 4 divided by 8R. 3 plus 3, 6, 6 plus 4, 10. So 10 by 8R, which I can write it as 5 by 4R. Therefore, R equivalent will be 4R by 5. I think that's option C. I hope that is correct. Very good. Arun, there is a lecture and session which I conducted just a few weeks back. Just search for Shreyas Sir Pro subscription. You will get that video. It will come out as the first or second result only. Shreyas Sir Pro subscription. Alright. So simple series and parallel. So a lot of people will leave these kind of questions. They'll get confused how to do this. Probably I'm hoping you will not leave this question. Okay, come on. So that's the answer. Let's get going to the next question coming up on your screen. Nakul, yes, you could have folded it that way, but that is even more tricky. You might make some mistake. You can do that. You can fold it like that and then remove it. That will be a two-step process. Instead, I have made it into one step. I just disconnect it and solve. Your process will be first folding, then find the equivalents, and then disconnect the wire. That will be a two-step process. Don't do that. Yes, user B, I am. Okay. Let's see. how to do this question. Now, a lot of people are going to use formulas, but let me tell you, you don't need any formulas for this. Simple brain will also be enough, even if you don't know anything about this. You should just know that resistance is linearly proportional to temperature. So if you have temperature on the x-axis, and if you have resistance on the y-axis, it will be a straight line graph. It's clearly mentioned. Okay, actually, yeah, this was 110, right? Okay, and this is 3.75, this is 0, and this is 3. The resistance of the wire is 3 ohm at 0 degrees Celsius. At 0, it is 3 ohm. At 110, it is 3.75. It is 3.75. So let's say it's a straight line like this. This is nothing but 110 degrees Celsius. This is 0 degrees Celsius. Now the question is, at what temperature will you have a resistance of 3.15? At what temperature will you have a resistance of 3.15? Guys, this is simple. Is it not like your straight line problem which you do in maths in coordinate geometry? y2 minus y1 upon x2 minus x1 is y minus y1 upon x minus x1. 2-point slope form method. Use that, you will get it. Very simple. So y2 minus y1, 3.75 minus y1, which is 3, upon x2 minus x1, 110 minus 0 is equal to y minus y1, 3.15 minus 3 upon t minus 0. Okay, so this will be nothing but 0.75 divided by 110 is equal to, this is nothing but 0.15 divided by t. Okay, shift it, so we'll get t is equal to 0.15 divided by 0.75. 110 will go on the top. This is 15 5s are 75, so this will become 1 by 5. So into, this was 110. Yeah, this was 110, so 110 over here. So this will be nothing but 22 degrees Celsius. Yes, that's option A. Yep. Is that correct? Everybody got it? So there was no need of any formula. You can solve it using this method also. Delta R is equal to R alpha delta T, or R final is R initial into 1 plus alpha delta T. But that will be lengthier. I feel this is simpler because you can directly convert it into a simple maths problem. Yep, as simple as that. Great. So we have got the answer as 22 degrees Celsius. Let's get going to the next question coming up on your screen. Okay, come on, my warriors, figure this out. So what you have over here is basically, there is a battery of 12 volts. Internal resistance is also given, and it is charged by some external battery of 132 volts DC supply and through a resistance. So the question is, what is going to be the terminal voltage of the battery? So I feel the first step that you should do is draw the diagram. Without drawing the diagram, probably you are going to make a lot of mistakes. So this is my battery. It has some internal resistance over here. Okay, so the battery of 12 volts and internal resistance of 0.5 ohm is connected via a series resistor, I guess, 11.5 ohm, yes, and it's connected across 132 volts. So 132 volts is over here. Obviously this will be the positive terminal, this will be the negative terminal. When you charge a battery, the current does not come out of the battery. That's the common mistake which people make. The current goes inside the battery. Understand? So the current is actually going inside the battery because it is getting charged. It's clearly mentioned. This is a charger, it is being charged and all of that. It is not giving current, it is taking current. It's charging itself. Okay. Now think of this 132 volts. Okay? If you are getting confused, sir, what is this 132 volts? If you do not like it, just treat it like a battery itself of 132 volts with 0 ohm internal resistance. Just think of it like that. Now just use your KVL or whatever and you will get the current value. Current is total voltage by total resistance. What's the total voltage? 132 minus 12 divided by total resistance, which is 11.5 plus 0.5. See if you understood why the minus sign, because this voltage and this voltage will cancel. Okay, so that's going to be 120 divided by 12, which is 10 amperes. So that's the value of the current. But that's not the question. What's the question? The question is, what is the terminal voltage? Okay, what's the terminal voltage? The meaning of the terminal voltage is, what is the voltage between these 2 points? This is the question. What's the voltage between these 2 points? Now, how do you find this voltage? Think carefully. It will not be E. It will not be E minus IR. It will be E plus IR. Yep, it will be E plus IR. Be careful about it. Remember, current is not being delivered by the battery. Current is being taken inside the battery. While charging, it is. So while charging, do not forget, it is E plus IR is the voltage difference. While discharging, it becomes minus. So what is E? It is 12. What is I? That's 10. What's R? That's 0.5. Yep. So that's going to be 12 plus 5, which is 17 volts. That should be answer C. Yep. So be careful. A lot of people make a mistake by putting E minus IR, and people will write down 12 minus 5, and that's not even there in the option, but still understand. Okay, very good. Now let's get going to the next one. 3 equal resistors connected in series with a battery dissipates P watts of power. What will be the power dissipated if the same resistors are connected to in parallel across the same battery? So when in series, this should be easy. I am hoping everybody will give the answer. I'm hoping everybody are going to give the answer to this question. Come on, my warriors, figure this out. This is very, very easy. Okay, Tushar saying P. Abhi, I know you need a break, but we'll give the break in some time. Just 5 more minutes. Okay, within 5 more minutes or something, we'll give a break. Thank you, Sam. All right, B, C. Come on, guys. You should be able to get it. Thank you, Naga. Prashant saying A. Guys, I'm wondering, how will you sit for 3 hours in the exam? And by the way, the exam time is also between 9 to 12 and 3 to 6. So you should have the habit for sitting for 3 hours continuously, because if your mind cannot think straight for continuously for 3 hours, you are bound to make mistakes, you know, by the end of 2 hours or something like that. So remember, that's a practice thing. You have to make your biological clock tuned to the examination time. Why do you think I'm conducting the exam and mock test at 9 o'clock? I could have kept it at 10 o'clock or even 8 o'clock. First time, when in series, okay, when in series, look at that, the power initially will be, well. See guys, the voltage is going to be same, the battery is same, okay, so V square by R equivalent. What's the equivalent R? It's 3R, because it is in series. Cool. Next time, when they are in parallel across the same voltage, the new power will be V square by R, because same voltage will be there for all of them, but there are 3 such resistors. All right, so there we go. What's the question? The question is V square by Acha. The question is, what's the new power equal to? Well, guys, you can see from here, V square by R is actually 3P. So into 3. Can you see that from here? So you can see that from here, V square by R is actually 3P, just from here. So just use that, and obviously you're going to get 9P, which is option C. Thank God, everybody got C option correct. Excellent. Beautiful. The answer is C. Very good. Very good. Excellent. Now, the question over here is, in steady current, the potential drop across the capacitor should be how much? What should be the potential drop across the capacitor? Well, The word used over here is steady current. The word used over here is steady current. In steady current, capacitor will completely block current. There will be no current over here. It blocks current. So whatever current has to flow, that current will only flow over here like this. These are resistors, so they will allow current, and that's it. It will flow only through the outer periphery. If I ask you what is the value of this current, that's simple, guys. I is the total voltage by the total resistance. What's the total voltage? Well, that's 2V minus V. By total resistance, that's 2R plus R. So it will be V by 3R. That's the current. But the question is not to find the current. The question is to find the voltage drop across the capacitor. How do we do that? I'll tell you what you should do. Use Kirchhoff's voltage law for this branch. Use KVL for this particular branch. Let's see what do we get. Use KVL. Start from here and go around it. So first thing that we encounter is this voltage, and I'm going from high to low, so minus V. I encounter a capacitor, voltage drop is Vc, which we need to find. The question itself is to find Vc. Next, I go like that, I encounter this resistance, so minus I into 2R. Last thing I encounter is this voltage. I'm going from low to high, I'm climbing, so plus 2V is equal to 0. Okay, let's see what do we get. So Vc and minus I is nothing but V by 3R into 2R. This minus V and 2V will partially cancel, and I'll just have V is equal to 0. R and R will also cancel, so Vc minus 2V by 3 plus V. So that's going to be V minus 2V by 3 is V by 3 is equal to 0. Therefore, Vc is equal to V by 3. That's the answer. Yes, option C, guys. Oh, a lot of you are saying D. No, it's not D, it's C. Be careful, be careful. It's C, guys. Yeah. Okay, cool. So that's the correct answer. Cool. Yeah, there we go. The answer for the previous one is also mentioned in the PDF. Yalini, don't worry about it. Tornado, you woke up when it's almost like afternoon and half of the lecture is over. Now, guys, I'm pretty sure you need some energy drink. Please energize yourself in 15 minutes. Break time. I know your mind has been working for a long time. But after this, magnetic effects, magnetic sources, that means Ampere's law, QV cross B, IL cross B, those kind of questions, dipole moment, magnetic dipole moment, torque and all of that, and then EMI, AC. This is what we are going to do. Okay, so see you guys in some time, in 15 minutes. Oh my god, Tornado, you woke up very early then. Chalo, let's get going. Those are your nightmares. Please energize yourself quickly, as quickly as possible. I'm putting up a timer out here. Okay. I'll give you a break for 17 minutes. Hello everyone, welcome. I hope you guys refreshed yourself. Welcome back Vasanti, welcome back Nancy, welcome back Yalini, Krishna, Kavya. Hello everyone, welcome aboard. So on catalysis there seems to be some technical issue because of which while streaming on both the channels probably it is not seen right now on catalysis. So I would like to ask all the catalysis students to probably join into Enthuse, and you can watch the lecture right over here. In case probably if you have some of your friends on catalysis and who probably message saying that there was some technical issue, you can just come out here. All right, so let's get going. I hope you guys are all energized. So now we're going to discuss magnetic effects, sources, EMI and AC. Before this we have completed the revision of electrostatics, Gauss's law, current, electricity and capacitor. So all these kind of questions we have just solved it. Let's get going to the first question on magnetism, and there we go. Okay, thank you Krishna for all the wishes. Welcome back everyone. There is a coil which has one turn and it will carry some current I. The same wire is wound into a smaller coil of 4 turns. Now the current, if the same current is passed through it, the field at the center will be, so you take a coil, you have one turn, okay, some field is produced. Now if you wind it 4 times, what will be the new field at the center? Come on, think about it. Let's see how many of you can get it. Oh my god, Rohini, this class started at 9 o'clock. Usually check out the timetable by joining our Telegram group, and also keep a track of our upcoming live sessions. You can see it very easily. Okay, some of you are saying 16 times. Interesting. So what has happened is that you have one coil and the magnetic field at the center will be mu naught I by 2R. Now when you make 4 turns, understand the numerator will get multiplied by 4 obviously, but the problem is even this R will reduce 4 times. Yes, this will reduce 4 times because the length of that wire is constant. That means 2 pi R is constant. So if 2 pi R into rather n is constant, because you will have n number of terms. So if n goes up, R comes down. N goes up by 4 times. So obviously R comes down by 4 times. So this 4 and this 4 will get multiplied, and hence the correct answer is 16 times. I hope that's fine. That's how it is to be solved. So a lot of people think it should just increase 4 times. That's wrong. N has also increased, radius also has decreased in the denominator. That's the reason why the field increases 16 times. Beautiful. Great. I hope you guys are warmed up now. Let's solve the next question coming up on your screen. Which is the most correct form of applying Ampere's loop law? Which is the most appropriate way of applying Ampere's loop law? Well, if you did not realize, the crosses here represent currents going in or out. Cross is going in, dot is coming out. This red line over here is the path, Ampere's path. So which of the following is the most appropriate option? Yes, Tyagarajan, we will take classes for 4th attempt also. We will not say that, oh, you are on YouTube, it's free. Why should we worry about 4th attempt students? Let them do whatever they want. No, we do not do that. Even if the exam gets postponed till next year also, I'll be conducting classes for the 4th attempt. Okay, don't worry about it. So we are all dedicated teachers out here. Okay, well, the logic behind this is simple. First, write down your Ampere's law, which is B dot dl is equal to mu naught I enclosed. Okay, mu naught I enclosed. Now LHS is fine. The problem is with the RHS. Now this I4 is outside current. So outside current should not even be considered. Next, in enclosed current, these 3 currents are there, but these two, I1 and I3, should have what? The same sign. same sign. Why? Because both are going inside. I2 should have opposite. So which option is there? Check this out. Where I1 and I3 are of the same sign, I2 and I3 are of the opposite sign. Check that out. I think there is only one option. Here you can see all the signs are same. Here also all the signs are same. This minus sign is there outside. This one, no. I think it is only this one. Option B, just check this out. So this should be the correct answer. B, very good. Okay. Chalo, let's get going to the next question, which is, this was done, okay. Next question. In the figure, there is a straight wire of length L. This is that wire. It's carrying some current. Remember, any current carrying wire produces magnetic field around it. Now you should remember the formula for finite wires, because the question is, find the field at this point at a perpendicular distance r from the end of the wire. Strictly speaking, this diagram should not be given. You should probably make the diagram on your own by the description given over there. Let's see how many of you get this right in a very quick manner, very quickly. Come on guys, post up the answers, my warriors, in the chat box below. Okay, B, sure. Okay, a lot of you are saying B. Interesting. Very good, very good. I think all of you have made a mistake out there. The formula for field is mu naught I by 2, no, not 2. It is mu naught I divided by, divided by 4 pi r, that's the formula, into sine alpha plus sine beta. Now I don't know whether you saw this, that one end is here, so the value of alpha will be 0, the other end is here. This is 45 degrees because this is L and this R is also given to be equal to L. So obviously this is 45 degrees. So sine alpha will be 0, sine beta 1, sine of 45, that's 1 by root 2 guys. Be careful. Yes, a lot of you got it wrong. Yeah. Purna, I doubt there will be any classes for 11th this week because of the schedule of all the 2021 students. We really sincerely apologize, because we are not able to do that. We are limited on resources. But meanwhile, please revise back, clear your backlogs, solve your books, and we will return with full force once, the 2021 students complete their third attempt. So till then, just hold on. Yeah, so the correct answer should be D, guys, or C. Yeah, it should be D, right? Mu naught I by 4 pi r, but here r is also going to be L. Keep that in mind. R is also going to be L. So option should be D. Very good. Yeah. Who said it was infinite? A lot of people make that mistake. That's why they write this as the answer. They think, sir, it's an infinite wire, mu naught I by 2 pi r. Some of the brainy people then they say, sir, it's semi-infinite. No, it's not even semi-infinite. So be careful, guys. Look at the ends. Be careful about it. That's why a lot of people make mistake here. It's okay. Now, that tells you, please observe the questions carefully. Don't just assume before you solve the question. Next question. There is a wire of length L. It has been turned into a square. You can see the square, PQRS. That's been made using this wire. You have bent it and made it into a square. There is a point P, okay, and R, which are connected to a battery. So these two ends are connected to a battery. Cool. If there is current I which is flowing through the battery, remember it's through the battery, not through the wires. Through the wires it could be something else. What's the field at the center of the square? Well, Kumar, I don't know. Is 65 enough? I mean, it depends, right? What you are looking for and aiming for. Like that, even 90 is not enough. So it depends on what is your aim, what's your percentile requirement, which college do you want to get into. That's how it is. Soma Sekhara Manepali, please hit the subscribe button, number 1. Please hit the bell icon, number 2. Number 3, join the Telegram group. It's a long time, more than 12 hours have passed. Exam has been postponed. Wake up, my dear student. Hello Nisha, welcome. Okay, so what do you guys say? Some Mac is saying D. What about others? Is the answer D or something? I don't know. What is it? It's a square wire. The currents are going to get distributed. Vasant is saying C. Pius saying D. Demogorgon. What the hell is that? Cat in a box. What am I supposed to do with it? La la la. La 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 la. What should I do with la la la? Harshini. D for Delhi. Okay. It's D for Delhi. Very good. See, first of all, the current will get distributed like this. I by 2, I by 2. Now, once the current gets distributed, it's very simple. This current will produce magnetic field like this. This current will produce magnetic field like this. Equal currents, equal distances, equal lengths. Symmetry is there. They will cancel. All the currents will cancel, guys. So, gone. The answer is 0 because they will cancel. In fact, for any such geometry, regular polygon, okay, if you have a regular polygon like this, if a current comes like that and it exits out here, doesn't matter which two nodes you are taking. Understand the field at the center will be 0 for a regular polygon and for uniform wires. So it doesn't matter where it enters from and where it exits from. It need not be exactly opposite. It can be from here and here also. Here and here, here and here. Doesn't matter. It's always going to be 0 because they will cancel out. Yeah, 0. Okay, next question. Calculations are required. You need to calculate. So there is a charge which is thrown. It's accelerated. The mass of the electron is also given. The question is, what will it do? Will it go in a helical path or will it go in a circular path? And what's the radius of that? Come on, you should be able to do it. Quickly, within 1 minute. My God, who is this person who is asking for shout out from Harshit? First of all, I don't see any guys named Harshit. Okay, come on, let's do this. So there is a charge, it's accelerated, mass is given, everything, all right. So basically the electrical energy goes into kinetic energy, and once that object has some velocity, it enters into a field, and it's clearly mentioned transverse. Transverse means velocity is perpendicular to magnetic field. And when it is perpendicular, it obviously goes in a circular path, and the radius of that circle is mv by qb. That's the formula. Okay. So, what is the electrical energy that will be gained? Charge into voltage difference is equal to half mu square or v square, whatever you want to write it. So, u will be equal to u square will be equal to 2qv by m. Acha, so u will be equal to root of 2qv by m. Substitute it here. So it will become m by qb, and that velocity is actually u over here, which will be 2q voltage divided by m. Now this q mm will get cancelled partially, and you will be left with this b will remain outside. So 2mv divided by q. Now you just need to substitute everything, guys. Oh, Nisha, don't worry, bacha. You can always be my student no matter which standard you are in, as long as you understand. But I'm pretty sure you will be a very regular student once you join in 11th standard. But yes, you're free to watch any of our classes as long as you understand and do not compromise on your 10th standard studies. So just substitute everything what is given. It's very simple. 1 by b. Where is b, man? This is 0.1, and root of 2 into mass is given, 9 into 10 to the power minus 31. Voltage is given. Where is the voltage? Where is the voltage? Yes, 18 kilovolts. So 18 into 10 to the power 3 divided by charge. It's an electron. So 1.6 into 10 to the power minus 19. Just check this out. Obviously, it cannot be a helix. So either it has to be a circle of this radius or this radius, just check it out. Ignore the powers of 10. Ignore the powers of 10. That's what we need to do. Remember, I have told you the technique. 9 2s are 18, 18, 18 under the root. So 18 by 4. Just check this out over there. Yeah. Yeah, so that should be 4.5s. You don't even have to calculate this. How many of you use my technique of ignoring the powers of 10? See guys, 9 2s are 18. This is 16. So 18 into 18 is 18 square, but it's under the root, right? So it will be 18 divided by root of 16. Root of 16 is 4. So 18 by 4 is 9 by 2, which is 4.5. That's it. You don't have to sit and calculate what is that power which is getting cancelled and all of that. It becomes very easy to solve the problem. Beautiful. So let's see. Yeah, answer is D. Yo, let's get going to the next question. Yalini, be careful. It's not root 9 by 2. You made a mistake while calculation. Just check that out. So there is a length of wire which is converted into a triangle PQR, and the current flowing in that loop is I. Now, if there is a magnetic field this way, the question is, what's the force on this element? Guys, I'm pretty sure many of you are going to make mistakes over here. Vicky bacha, I'm taking lots of classes bacha, aisa nahi hai. I'm taking the topper batch of 12th standard plus all the micro courses which I just finished. All of them are now even available as recordings for all the students of 11th and 12th standard. So if you are a pro subscription user, HC Verma course, IE Rodov course, derivation micro course, then problem solving course for JEE and NEET, all of these are available. Okay. And plus, yeah, I need to manage the department. Okay. Plus, I am also on YouTube. So, you know, I am occupied almost everywhere. Come on, let's see. Gokul says A. I knew this. Yes, Shyam, if you want to clear JEE Advanced, you should solve IVE Rodo. There is no doubt about it. Okay, I knew this. First of all, magnetic field is here, length is here. The angle between them is 120 degrees. There are a lot of places where people will make mistakes, and let's see. Vicky, when just watch that video which I conducted some days back, pro subscription courses of Shreyas Sir. Just search for it. I have explained in detail how to get into that. Okay, just follow those methods. Achha. The force is I L cross B. That cross you can write it as sine theta. Now I is I. Well, that B is B. Sine theta is sine of 120 degrees. Okay. Now sine 120 is nothing but cos 30. And you can write cos 30 as root 3 by 2. Now I know what you guys are thinking. Oh, it's ILB root 3 by 2. That's why you guys marked A. Be careful. Be careful. That's why you guys make silly mistakes. You have not read the question carefully. That's a wire of length L is shaped into a triangle. That means each part has a length of L by 3. L by 3, L by 3, L by 3 is L. So this is actually L by 3. Understand, be careful. Love you too, Vicky, don't worry. Okay, so this is L by 3. This is L by 3. Oops, sorry. Yeah, this is L by 3, guys. Be careful. So root 3 cancels, and I will have I. Yeah. Oh, where is it? Yeah. I, L, B, and I'll have root 3 over here and 2 over here. So is 2 root 3 there? Yes, option C. Yo, how many of you made that mistake? How many of you made that mistake and marked A? How many of you forgot that this length is actually L by 3? Please put it up and put an embarrassing face. Hide your face out there. Yeah. So the correct answer is actually C. Very good. Very good. I'm very good, Arjun. Rohan made that mistake. Beautiful. Come on. Excellent. Let's go to the next question then. Two long wires P and Q are held perpendicular to the plane of the paper as in the screen, whatever you're observing, and they are separated by 5 meters. Both of them are carrying currents in the same direction, either in or out of the plane. What is the field exactly between the wires P and Q? Come on, draw the diagram. It should be easy. Again, there is a chance that you are going to make a silly mistake. I'm just hoping you do not make that silly mistake out here. Oh my God, Aman, come on, join in, bacha. You missed some interesting questions. I'm pretty sure you're going to make a mistake out here. Be very, very careful, okay, with the signs, directions and all of that. So there are two wires held perpendicular to the plane of the screen. This is the screen, perpendicular as in like this, either in or out. So let's say I call this wire P and this is wire Q. Okay, there's separation between them, that's 5 meters. All right, they are carrying currents in the same direction. This one is 2.5 amperes, this one is 5 amperes. Now you are standing here. So the question is, what's the magnetic field here? First of all, this wire, okay, this one over here will create, you hold your right hand, curl your fingers like this, only then the thumb will come towards you, will create a magnetic field like this. This wire, again you hold your thumb towards you, fingers will curl like this, you can see the magnetic field created will be like this. So don't you see, at this particular point the magnetic field will not add but cancel. Yalini, be careful. It's not, a question is not what is the force of attraction. The question is, what is the magnetic field between them? Yes, two wires flowing in the same direction, there will be attraction. So the answer for this will be mu naught into current divided by 2 pi r. This is the midpoint, so the distance is 2.5 minus mu naught, and I is nothing but 5 amperes divided by 2 pi r. It's again 2.5. Do you see that? So that's why this minus sign, because both are in opposite direction. So now you can see what is going to happen. 2.5 goes, and mu naught by 2 pi minus mu naught by, or rather I can just say mu naught by 2 pi 1 minus 2, which is minus 1, so minus mu naught by 2 pi. But I'm only interested in the magnitude of the field, so mu naught by 2 pi should be the answer. Yep, answer C, only the magnitude. Okay, only the magnitude, that's all. Great. So let's get going to the next question. Do not add, because if you add you will get a wrong answer. All right, here it is. There is a loop which carries current. Oh, by the way, more than one options are correct for this. I know you will be like, sir, multiple choice questions do not come in the examination, but you never know. It can come like a multiple choice as a single choice. Like they will say option A and B are correct, option A, B, C are correct, none of them are correct, all of them are correct. So that way you can get a multiple correct option question as a single choice. So there is a loop in uniform magnetic field, then which of the following is possible? More than one may be correct. Pramesh saying A and B, Yalini saying A and B. Come on my warriors, figure this out. Read the question carefully. What do you think is the correct answer? Sure, everyone, come on. It's a uniform magnetic field. Now I have told you this. Whenever you have uniform magnetic field and you have any loop, the net force acting on it is always zero in uniform field. So it will always be zero. So C option and D option are wrong. Torque, well, the torque may or may not be there. In fact, torque is M cross B. This diagram is just for representation. This is not the actual diagram. This is just a representation. It's not necessarily a circular loop. So the torque may be zero, it may not be zero. So both are possible. It depends on the orientation of magnetic field and magnetic moment. So hence the correct answers are A and B both. Very good, excellent. A lot of you got it correct. Yes, some of you are already saying uniform field F is zero. Yes, that's the rule. Okay, Let's do the next question. There are two long parallel current carrying conductors. They repel each other. We know that two wires can attract or repel each other, okay, depending on the directions of the current. Now, if the currents in them are doubled and the distance between them is halved, current is doubled, distance is halved, then the new force will become how many times? Come on, come on. Prashant will have a formula session in the next 2-3 days, okay? Don't worry. We're definitely going to have it. Yep. Now comes this question, okay? What is the formula that you will use? See, the formula that you need is the force per unit length is mu naught I1 I2 by 2 pi d. This is the formula for force of attraction or repulsion between two wires which carry current. So that's how you solve this using this formula. You should know this formula. Now it's clearly mentioned that the currents are doubled. I1 is doubled, done. I2 is also doubled. D is halved. So this 2 goes on the top. 2, 2, 2, 8. 2 to 2 is not 6. 2 into 2 into 2 is 8. So that's why the answer is C, 8F. Very good. It's not 2 times, it's 8 times. Okay, next question. I can see current, electricity with EMI and magnetism. Wow, beautiful question. There is a wire. It's moving with speed V. And you can see there is some kind of a circuit with some resistances out there. Magnetic field is inside. Every value is given, speed, everything. What is the current in the frame? Because you are moving it, so there will be some EMF. Is it 8, 6, 4 or 2? Figure this out. Beautiful question. If you know the trick involved of current, electricity, it will become very easy. Yep, somebody is saying Wheatstone's bridge. Very good, Wheatstone's bridge. Acha. Come on guys, figure this out. Yes. Come on my warriors. What should be the correct answer? The current induced in the frame should be equal to how much? Acha, it's a Wheatstone's bridge. Sure, pakka. Is it a Wheatstone's bridge? Really? Think about it. Be very careful. Guys, look at the terminals out here. Look at the terminals. And then understand, is it actually a Wheatstone's bridge? Okay, people are clearly confused now. See, first of all, EMF is BLV. That's okay. Okay, the EMF is BLV. Current is EMF by the R equivalent. So EMF is BLV. Everything is given. B is given. L is, where is that L? 15 is given, V is given, everything is given. The only problem is for the R equivalent. Be careful. It's not exactly a Wheatstone's bridge because it would be a Wheatstone if this is how it was arranged. The current comes in like this and goes out like that, then I can ignore this. Understand, the current is coming from the top and going from the bottom. This is not exactly a Wheatstone's bridge. So just solve it normally. This is two resistors in series. Two resistors in series. So 2 and 2, 4. These two also in series. 2 and 2, 4. 4 and 4 in parallel. So it will become 2 ohm. Correct? Now 2 ohm and 2 ohm also in parallel. So it will become 1 ohm. So this will become 1 ohm, guys. 2 to 4, 2 to 4 series, okay? This 4 and this 4 parallel. So 4 and 4, 2 ohms because it will become half. That 2 and this 2 also in parallel. So it will become 1, that's it. Is the internal resistance also given? And the resistance 1 ohm. The square frame of PQR resistance 1 ohm is moved with the speed of which is perpendicular to the plane of the frame. Oh yes. Wait a minute, there is also this internal resistance over here. This internal resistance is also there. So we have to assume that this resistance is also 1 ohm. So then this will be 1 plus 1 ohm. So this will be BLV divided by 2, and this will be also 2. Yeah, somebody just pointed. Yeah, the frame also has a resistance. So this will be by 2. Now this 2 and 2 will cancel out. Now check this out. What will you get? 20 into 10 to the power, yeah, minus 4. So this is 2 into 10 to the power minus 3. Just check this out. Are you getting it? As 2 milliamperes. Yep. The frame also had this resistance. So this frame has 1 ohm resistance. So I have to add that 1 ohm to this 1 ohm resistance. Correct. Yep. Else the answer would have been double. It would have been 4 milliamperes. So first thing that you learned in this problem is that the moment you see a diamond, do not jump to the conclusion that it is Wheatstones. So it is not a Wheatstone. Please keep that in mind. Okay, the answer is 2 milliamperes. Let's get going to the next question coming up on your screen. There was a EMF of 15 volt which is applied to a circuit which is having 5 Henry inductance and 10 ohm resistance. So only inductor is there and resistance is there, no battery, so it is discharging. What is the current ratio at infinite time and at 1 second? Figure this out. What is the current ratio at infinite time and 1? Oh, there is a EMF of 15 volts applied. So this is definitely a charging circuit. So there is a charging circuit. So you have the battery out here, you have the inductor, and you have the resistor. Okay, so the current is definitely going to grow, and we know the formula for it. It's nothing but, I naught into 1 minus e to the power minus RT by L. That's the formula. Yep. Let's do this. So first of all, what is the current at infinite time? It will be I naught 1 minus e to the power minus infinity. Okay. What is the current at 1 second? It will be I naught 1 minus e to the power RT by L. Okay. Now just divide both of them. So I infinity divided by I1 will be equal to I naught cancels. 1 minus e to the power minus infinity is 0 divided by, remember I naught has cancelled, 1 minus e to the power R. What is the value of R? That's 10. Time is 1. Okay, if you want I'll just put it as RT by L. This T value is 1 second. What is the value of L? L is 5 Henry. Okay, with a minus sign. Now this will become 1 divided by 1 minus 10 by 5 is 2. This will become e raised to minus 2. This will become 1 by 1 minus 1 by e square. Now take the LCM. It will become 1 by e square minus 1. That e square which is there below, you can take it on the top. So is there an option like that? Yes, it is there. B. You can see that. Beautiful. So it's just based on formula, nothing else, and pure mathematics. Nothing great about this question. Okay, you should get this question in case it comes in the examination. Now this is a tricky question. Let's see how many of you can get this. Lot of concepts and multiple chapters involved in this. Magnetism, EMI and all of that. So you can see there are 2 coils. Smaller coil, bigger coil. Resistance of the inner coil, the blue one is R. The current in the outer coil is increased from 0 to I. Then what is the total charge which will flow in the inner coil? Now first of all, what chapters, what concepts are involved? When you pass current in the outer coil, okay, and change it from 0 to I, this current in the outer coil will create magnetic field, correct? Now because you are increasing the current, the magnetic field will increase. Because of that, flux will increase. And if the flux through this small coil changes, what does it create? Obviously, change in flux creates EMF, induced EMF, Faraday's law. If EMF is produced, what will it create? Current. So that's why current will flow. And because of that current, charge will flow. So many things are there. So let's do it step by step. So here is what I will do. The current in that small coil, okay, the current in that small coil will be EMF induced by the resistance. Okay, so what is that resistance and what is that EMF? EMF is del phi by del t, and resistance is just R because it is given. Current is the charge which flows upon the time. Clearly this time and this time cancels, so Q is del phi by R. Okay, del phi by del t gone. Now what is change in the flux? It's final minus initial flux. Final flux is BA and initial flux is 0, so that divided by R. Remember, the current goes from 0 to I, so initial flux will be 0. That's why I have put 0 over there. Cool. So the value of the charge will be B. B because of the outer coil. So what's the magnetic field because of a current carrying wire? Recollect, it is mu naught I by 2R. What is R? It is B. Okay, B is nothing but mu naught I by 2R. That's the value of B. What's this area? Be careful. You have to just worry about the flux through this coil, because EMF is induced here. Current is flowing here. This is induced current. This is induced current in that. So flux in this area, which is pi A square. Okay, divided by R, of course. Now check if there is an option which is matching. Rutvik, we are going to have, like I said, formula revision session in the next 2 or 3 days. Okay, don't worry about it. So how many of you got it? Is it A, B, C or D? I think that 2 is there over here. R is there, B is there. So you should have R and B in the denominator. So I think it should be option A. Yep. Correct. You can see that. So lot of concepts. If you understood this question, trust me, you understood so many other concepts. That's why I'm taking these questions in the rank booster series. Understand? You know, if you just solve simple questions, then it will be like, I know this. But when you put these concepts together, that's when you realize the actual, truth, whether you know these concepts very well and can you link these concepts or not. Beautiful. Let's get going to the next one. There is a square coil, resistance 2 ohms, 100 turns, side 10 centimeter, placed with a plane, making angle 30 degrees with uniform field. Now in 0.5 seconds it rotates and becomes parallel. What is the current? Again based on EMF. So a lot of things are involved. I feel we should start with the diagram first. Without diagram, I think we are bound to make a lot of mistakes. Trust me on this. First situation, the plane makes 30 degrees with uniform field. Okay, so this is my plane of the coil and this is the magnetic field and that is making 30 degrees. This is the coil. Now a lot of you might be thinking, sir, I know how to calculate the flux initially and before and later on. I will find change in flux and that will give me the the approach for induced EMF. Yes, you need to calculate changes in the flux. Now what is the formula for flux? Flux is BA cos theta. Now do not do this BA cos 30. If you do that, it's wrong. What is wrong in this? What's wrong in this? Can you let me know? There's something wrong over here. Something wrong over here. I don't know whether you realize this. You cannot write it as BA cos theta. Be careful. There's something wrong. The moment you write it, you will get a completely different answer. What's wrong? What's wrong in this? Come on, my warriors, figure this out. Yes, science lover. Looks like you really love science. You should not measure this angle, you should actually measure this angle. This is the vector, M vector, or rather the area vector. Be careful. Area vector is over here. It's always perpendicular. So actually speaking, this is not 30, this is 60 degrees, and cos 60 is half, so it's BA by 2. That's the common mistake which people do. Yep. Now, second time, until its plane becomes parallel, the coil is like this and B is like this. That time the area vector will be here and the final flux will be BA cos 90, which is 0. So that's how you calculate the fluxes. Why is the flux needed? Because I need change in flux. Why? Because I need Faraday's law for finding the current and EMF. Now it's simple. The current is EMF by resistance. EMF is change in flux by time, and this is resistance. Change in flux 0 and BA by 2. Can you see the change? It's just BA by 2. So BA by 2 into time into resistance. Now just substitute everything beautifully, you will get the answer. What is the value of B? Yes, it's 0.1. What is the value of A? Side is 10 centimeter. 10 means it's 0.1. 0.1 square into 100 turns. So do not forget to multiply by 100. Okay, this 100 turns is also very important. 2 is 2. Time, where is the time? 0.05 seconds. And resistance, well, that's 2 ohms. Just check this out. If this is how I'm going to get it, and you will probably get the answer, guys, quickly. Check this out. What is the answer finally? Let me know in the chat box. Come on. What is it? Come on, my warriors. Yeah, ignore the powers of 10. Remember that method, you can use it. 2 into 5, 10. So all these are powers of 10. Just ignore it. There is only 1 by 2 over here. 1 by 2 is 0.5. So don't even think. Just directly mark 0.5. My method works beautifully so many times. Just use that. Yeah, ignoring the powers of 10. That's it. Beautiful. Okay. Chalo. Let's get going to the next question. Here it is. Rajaram, I doubt BitSat will get postponed, and if it gets postponed also, they will notify it well in advance. Now it's almost like 15-17 days just before the exam. I doubt it. Yeah, always welcome, Abhishek, and glad you are learning a lot. Keep learning like this only. Okay. Calculate the potential difference between the points A and C and B and D. Calculate the potential difference between the points A and C and B and D. Two answers are needed over here. There is a comma between both the answers. Let's see how many of you can get this. Priyanka, actually I don't use Telegram much unless and until it's official communication. So usually my Telegram is flooded with messages from random things. So you know, it's like a big chunk of unread chats. I hardly see it. Yeah. So Instagram, yes, I use it. Okay, 0B, what is it? The correct answer is simple, guys. It's C. I'll tell you why. You have to use this formula. EMF is L vector dot V cross B. This is the actual original formula. L dot V cross B. Now if you notice over here, between A and C, this is the length vector. Okay. Now velocity is here, B is inside. V cross B will be here. This is the direction of V cross B, of course. Now when you take the dot product of L and V cross B, the angle between them is obviously 0 degree. So yes, the answer for the EMF will be length, which is 2R, into V cross B will be just VB, and it will be cos 0 because of the dot product. The angle between them is 0 degree. Now when you take the other side, BD, the length vector is like this. V cross B is perpendicular. So that's why for the other part, length is 2r, V cross B is VB, it will be cos 90. Cos 90 is 0. That's why the answer is 0 for the second part. And it's 2 VBR for the first part. Always replace the two ends with a wire and get the answer. Use this formula. First do V cross B using right hand rule and then take the dot product of that vector with L vector. Okay. What is special today? Today the special thing is I'm taking a lot of classes. And I'm standing here for you guys since more than 3 hours. And after this I'm going to conduct my regular classes, and obviously my usual meetings and other things are going to continue. Okay. Chalo, let's see what you guys are going to do. Oh, by the way, I am planning some special video for you guys. I'll probably put it up tomorrow. Motivational video for all of you, especially for all the students who are going to give the examination, and one special trick for all of you. Oh, Priksha, I haven't replied to your Insta message, is it? Okay, definitely I'll reply. Okay. How many hours left? Ruchita is tired. She's given up. I have not given up. I'm still standing over here. I'm going to continue. Okay. So the question is, what is going to be the power or what is the heat dissipation rate in the circuit? Question is rate of heat dissipation. The rate of heat dissipation means power loss. And what is the formula for power loss? Is there a resistor? Yes. So obviously power is lost across the resistor in the form of heat. So heat loss rate. So that is going to be I squared R. But resistance is not just R. It is R plus internal resistance. So R plus small r. What's the current? Current is EMF by resistance. Okay, cool. Into R plus R. Okay. Now, one of the R plus R will cancel out. You will just get R plus R. What is the EMF? Oh, I know the velocity. So it is just B L V, right? Or BBL whole square. So that should be the answer. Just check this out. Is that understood, guys? What we have done? B square L square V square divided by R plus R. Nothing great about it. You should just be aware of the formulas and you should be able to link everything. You can see that B square L square V square by R plus R. Nothing great. As simple as that. If you miss that small r, you will probably get negative marks. Okay, next question. There is one loop here, another loop here. There is a long wire producing its own magnetic field. When you move this loop like this and this loop like this, which loop will have current, and if it has current, which direction it is? Figure this out. Govind, I'm very good. Okay, fine, sure, Preksha. Chalo, come on, figure this out. Come on, my warriors, you should be able to do this. Think about Lenz's law, think about Faraday's law, think about where is flux changing, think about the direction of the field because of this long wire, and see where it is increasing, decreasing, or not changing. That's it. So that's a wire. Hold your right hand, thumb upwards, fingers curl like that. So the magnetic field will be like this. Correct? This is how it will be. And as you go far, you can see the field lines will become less dense. As you go close, the field lines will become more intense. Now, can you see, if you go like that, there is no change in flux. When you bring that coil here, there is no flux change. Hence, there is no current in the first situation. Second situation, when you take it here, it's becoming weaker. So flux is reducing. It's reducing. What will happen by Lenz's law? If flux reduces, you should strengthen it. If flux increases, you weaken it. Where is the flux? Inside. Do you see crosses? Flux is inside. It's becoming weak. It's becoming less. You need to give it strength. You need to produce more magnetic field inside. How do you produce magnetic field? By creating a current clockwise. You create a current clockwise, there will be a flux which will be created inside. So no current and there will be a clockwise current. That should be B. Very good. Some of you said A and something else. Well, the answer is B, guys. Very good, very good. Let's get going to the next question coming up on your screen now. Wow, interesting question. There is a field and the direction of it is perpendicular to the plane of a square loop made of a wire. The wire has a diameter of D and a total length of L meters. The magnetic field changes with time at some rate dB by dt Tesla per second. The induced current in the loop is close to what value? Figure this out. You have to write in terms of variables. All the variables are given to you, guys. All the variables are given to you. Figure this out. What will be the answer? Think. So, the wire has a diameter of D and total length of L. First, draw the diagram and think what will happen. Okay, so we have a square loop like this. Okay, and resistivity is also given, I believe. Yes, the resistivity is also given. Okay, now the question is, you know, if you have a magnetic field like this and if it is changing, obviously flux is changing, current will be produced and all of that. So I will be equal to E by R, EMF will be equal to del phi by del T, okay, into R. Now resistance, is there a formula? Yes, rho length is the length given, the diameter, a total length of L. Yes, L by A. That A will be that area of cross section, that small area of cross section. I hope you realize it. There is a small area of cross section of that wire. So I'm just going to put that A over here. So next step, what will happen? Okay, this will become A by rho L separate. Del phi by del T, I can write it as d by dt, or rate of change of B into A. B into A. I hope this is fine. Yep. Is that correct? Check this out. This flux is through this entire coil. Okay. So this A is different from this small a. Please understand, this small a is for the cross section of that wire. This A is the area of the loop. When I say area of the loop, it means this complete area. Okay, cool. Now, what next? What next? Look at this. This will become A by rho L. B is changing, area is constant, so take out A outside and you will be just left with dB by dt. You'll be just left with dB by dt. Cool. Now what? Well, guys, come on, think. This A, capital A, area is nothing but L square. So this will be A by rho L, okay, into, but wait a minute, the total length is L. So the length of the side of the square will be L by 4. L by 4. That means this will be L by 4 whole square into dB by dt. Oh, wait a minute, there was R, everything. Yes, everything is written properly. Now this will become, one of the L will get cancelled. So you'll have A, L by 4 rho into dB by dt. Now what to do? This A, this is the area of cross section. Remember, the metal wire has some diameter. So that's it. This needs to be substituted as just pi radius square, which is pi into d square by 4. That's it. So that will be the final answer. Very good. So, my God, who is this Trimbak wants to improve from 99% to 100%. Rimbak, how about this? Ping me, man. It's depends on many things. 99 to 100% is very personalized approach. There is no general approach. So how to increase from 98 to 100, or that depends on where you are making mistakes and all of that. It's a very, very personalized thing. Yep. So that's the answer, guys. So we can do that. Cool. Let's get going to the next question. We have come to AC. The last few questions are on AC, guys. Let's do this. Okay. So what we have over here is an AC generator which consists of a coil of 50 turns. Area is 2.5 meter square, rotating at 60 radians per second. Uniform field is also given. The resistance is also given. What is the current flowing through it? Do you remember the formula for EMF generated in a coil which is rotating in field? I had given you this. Was the EMF generated for a coil which is rotating in a magnetic field? I have told you. Remember? Yeah, come on. How many of you remember it? Nikhil Reddy says yes. Come on, type it out. Born. I had told you about born. So EMF was born sine omega t. So current, which is E by R, will be born by R and sine omega t. This will oscillate, but this one over here, this is the max current. This is the current amplitude. This is the maximum value, because maximum value of sine is 1. So that's why this is the maximum current. Great. So what next? Find out the value, substitute everything is given. Just substitute. Max current will be equal to B is 0.3 omega 60 radian per second. So into 60 into area is 2.5. Okay, into N, number of turns 50 divided by resistance. Is the resistance given? 500. So just do that and you will get the answer. Yep. Born sine omega t. Very good. BL omega square is different formula. Be careful about it. Yeah. So just do the math and you will get the answer. Cool. So yes, 4.5 ampere should be the answer. Just check that out. Okay, when you do it. All right. Let's move on to the next question. Here we have, there is a wheel which has 8 spokes and it is rotating. Each of them 60 centimeter long. Speed is 100. The magnetic field is perpendicular. Earth's magnetic field is also given. Find the EMF induced. Well. First of all, try to visualize what is happening. There are these spokes like this and they are rotating, each of length L. Magnetic field is like this. This is your B. So what is the EMF induced in any one coil or any one spoke? There is a formula, guys. I don't know whether you remember, when a coil rotates or when a wire rotates with angular speed omega, the EMF is given by half B L square omega or omega square L or omega square L square. Do you remember it? Okay, very good. Who is that? Devasri. Very good. B L square omega. Yes, B L square omega. That's what you will get as the answer. So now each spoke will have the same EMF. All of them will have same EMF. So the question is, find the induced EMF between the axle. This is the axle, by the way. This is the axle and the rim. This is the rim of the wheel. So that's the question. So standard formula. So just substitute everything. B is given 0.3 into 10 to the power minus 4. L 60 centimeters. So 0.6 whole square. And omega 100 revolutions per minute. 100 revolutions. So into 2 pi divided by 60. Yeah, because it's 100 revolutions. Each revolution is 2 pi radian. 1 minute is 60 seconds. So do not forget to multiply it with this factor. You should get the answer then. Okay. So what you need to remember is that when you have a length which is moving in magnetic field, the EMF produced is BLV. But if it is rotating, then remember, I have derived this in class. but you can also remember this right now. It is half B L square into omega. So two different things. If it rotates, if it translates, do not forget that. Yep. Chalo. So do that calculation, you will get it, I'm pretty sure. Okay, let's get going to the next question coming up on your screen on inductance. An inductor of inductance 100 millihenry, resistance 50 ohm, connected to 2 volt battery. The time after which the current will fall to half its steady state value. Come on guys, you can get this very easily. You can get B or D. Okay, well, let's see. Question is for the current to fall to half its steady state value. Current is given by I naught e to the power minus RT by L. That's the formula, correct? Now its steady state value is I naught. So this current should be I naught by 2. This is equal to I naught e to the power minus RT by L. I naught goes. So 1 by 2 is equal to, instead of putting this on the top, I'll put it like this, RT by L. Flip it, so you will get e raised to RT by L is 2. You convert it into logarithmic form. So ln2 is equal to RT by L. Next, rearrange it. Okay, so this was RT by L. So the question was to find time, right? So time will be L into ln2 divided by R. Now what is L? 100 millihenry. 100 into 10 to the power minus 3. ln2, just keep it as it is. Divided by resistance. Where is the resistance? Well, that's 50. 100 by 50, that's 2. 2 into 10 to the power minus 3 into ln2, which is 2 ln2 milliseconds. This was in seconds, this is in milliseconds. So that's answer D, I suppose. Correct. Lot of you made a mistake, I guess. You told B for some reason. I'm not sure why. You probably missed some 2 or added some 2 somewhere else. So be careful. The answer was D. Okay, now this is a brilliant question. Let's see how many of you get this. Come on, I'm going to give you 1 minute for solving this question, guys. Figure this out. Okay, 1 minute, not more than that. Let's see how many of you can do this. There is a current flowing through this resistor, battery is there, inductance is there, rate of change of current is there. Question is find the voltage difference between these 2 points. Oh my god. The answer just came out to be C. My bad, guys. I was not supposed to show you the answer. Let's go behind, please. My finger just touched. Okay, let's try to solve this, assuming we don't know the answer. So the current is given, and the voltage is given, the inductance is given, the rate of change of current is also given. So how do we find the voltage difference? Use incomplete KVL. So use Kirchhoff's voltage law. Start from A. So voltage at A minus I is the current given. Where is the current? Yeah, 5 microampere minus 5 into 10 to the power minus 6 into R. Okay, this is a battery high to low, so jump down by 15 volts. This is an inductor, and it is clearly mentioned that the current is decreasing. Whenever the current decreases, inductor does not like it. It tries to act like a battery, which will help the current. Help it. Because the current is decreasing. So it does not like the decrease of current. Inductor always opposes the changes in the current. So the EMF equivalent, remember, is L di by dt. That's the equivalent EMF of an inductor. It behaves like a battery of this value. So what is L? L is, where is the value of L? Yeah, 5 millihenry. That's 5 into 10 to the power minus 3. And di by dt, that's given to be 10 to the power minus 3 is equal to VB. Now, the best part, guess what? 5 into 10 to the power minus 6 and 5 into 10 to the power minus 6 gets cancelled. So, VA minus 15 is equal to VB. So, VA minus VB is equal to exactly 15. Hence, the answer is C. Done, done, are done. Yo! So, there are multiple things involved here. We have used Kirchhoff's voltage law from one point to the other point. Start from one point, whatever you encounter, add or subtract the voltages. Because you are going in the direction of current, the voltage will drop across the resistor. Across the battery, high to low, so decrease. For the inductor, why is there a plus sign? Because it is helping it, so plus in this direction, low to high. You can see low to high. So that's why plus L di by dt. So when I finally reach here, I encounter all the drops and the rises. The final voltage is B. I'll solve it and I get the answer. Okay, cool. That's the answer C. Beautiful. Yo, let's get going to the next question. There is a circuit which has some self-inductance, 1 Henry, carries a current of 2 amperes. To prevent the sparking, when the circuit is broken, a capacitor which can withstand 400 volts is used. What is the value of the capacitance that you will connect across the circuit? Yes, you need to watch not only these classes but also all the other lectures which are conducted not only on this channel but also the crash course. If you take up the crash course and solve the mock test, that's when you will actually benefit out of everything. Oh my god, okay. Now what is exactly happening? The circuit has some inductance, it has some current. To prevent the sparking, you need to withstand that spark, and you have a capacitor which can withstand 400 volts. What is the capacitance required? So what is happening is basically that inductor is there and you connect it across the capacitor. Whatever energy was stored here in L will be transferred to the energy in the capacitor, because it has to withstand that thing, and when the circuit is broken, it has to withstand that much energy. It will be transferred from the inductor to the capacitor. So the logic is half Li square will get that transferred to half CV square, which is the capacitor. The question is C, right? Find out C. 2 gets cancelled. So Li square by V square. What is the value of L? 1. What is the value of current? 2. What is the value of voltage? 400. Okay, brilliant. 400 square. So this is 1 by 200 square, which is 1 by 4 into 100 square. Yep. So this will be equal to 0.25 into 10 to the power minus 1 by 4 is 0.25. This is 10 to the power minus 4. So that will be 25 into 10 to the power minus 6, which is B. Option B should be correct. Yes, that's how it is. Okay, cool. That's the answer. Let's get going to the next question coming up on your screen. Last few questions, 3-4 questions are there, and then we are done. Okay. The RMS value of a AC current, which when passed through a resistor produces heat 3 times as produced by a direct current. The question is, what is the RMS current? Now, remember, the power loss in AC circuit is given by IRMS square into resistance. So in AC, IRMS square into R is the power loss. Whereas power loss in DC circuit is just given as I squared into R. I is the DC current. It is given that the heat produced in AC is 3 times of that in DC. So this, understand, this whole value is 3 times of this value. That's what is given. Now you just need to solve it, nothing great. First of all, R and R will cancel. See what is left. IRMS square is 3 I square. What is the value of current? Current is 2, so 2 square. It's given, direct current of 2. So that IRMS will be root 3 into 2 ampere, which is option D. Option D, as simple as that. Done. Clear? Shall we go ahead to the next one? Okay, so that's how you need to solve it. Beautiful question, guys. Great. Okay. Next question. When resonance is produced, everybody should get this. in LCR circuit, then which of the following is not correct? When resonance is produced, which of the following is not correct? This is very easy. I'm expecting everybody will answer this. Only one of the option is not correct. Come on, this is the fourth last question, I guess. Figure this out. When resonance is produced, one of the option is not correct. Which is that incorrect option? Read the options. Current in the circuit is in phase. Inductance and capacitance are equal. If resistance is reduced, voltage across capacitor will increase, or the impedance of the circuit is maximum. Figure this out. C or D? Interesting. Oh, well. In resonance, we know that the actual EMF, complete EMF and the current will be in phase. In fact, the value of phi is 0 degrees. That's known. In fact, it also happens that if you draw the resistances, XL will be on the top, XC will be below, resistance will be here, current will be here, and you will see this and this are equal. That's also true. And if resistance is reduced, because of this, since current is EMF by R, the moment you reduce resistance, the current increases. And the moment the current increases, voltage across the inductor, which is I into XL, because this current increases, this voltage also increases. So this is also correct. Impedance is not maximum. This is wrong. In fact, it is minimum. And Z is just R. There is nothing over here. The value of X is 0. So it's the minimum value. So option D is wrong. That's how you get it. Vatsalya, which background music? No man, I'm not playing any background music. But there is azan going on somewhere. So maybe that's what you have heard. Why would I play music when I'm teaching? Okay, cool. Yes, it's minimum. Next question coming up on your screen right now. There we go. Third last question on your screen. A wire in the form of a loop of radius r lies with its plane normal to a field. If the wire is pulled out to take a square shape in the same plane in time t, then the EMF induced. Beautiful question. I'm pretty sure you can do this on your own. Come on, 1 minute for you. The wire is pulled and instead of a circle you make it a square. So what will be the EMF? Come on, very simple geometry. 10 standard geometry is required and the concept of Faraday's law. Faraday's law says flux change by time gives you EMF. I think you can find flux change because area is changing. That's your hint. You should get the answer now. Devashree, my body is tired, but mentally probably I'm not. But yeah, I'll continue. That's not a problem. Okay, figure this out. Oh yes, thank you for reminding me. D is the answer. Wow, good, very good. So this loop, you have changed it into a square. So this radius was r, the length will be 2 pi r. You make it into a square. Remember, the square side length is L, but 4L will be, or rather I would say this becomes a square of side A. 4A, okay, A will become L. Therefore 4A will be 2 pi r. Therefore A will be pi r by 2. I need this. Why I need this? Because to find induced EMF. EMF is change in flux by time. Time is T, it's given. okay, in time t. Change in flux is B into final area minus B into initial area. So B is common, so B by T is common. Final minus initial, square area and circular area. So who is more? I think this guy is more. Okay. Anyways, even if you get a negative sign, it doesn't matter. So just take the mod value. So that will be nothing but pi r square minus a square. Yes, a square. So this will be equal to B by L pi r square minus a is pi r by 2. So pi square r square by 4. So pi is common, r square is common. So B pi r square. Oh, wait a minute, this was t, right? Yeah, B pi r square by t, and there we have, yes, so 1 minus pi by 4, because this is pi square, this is just pi, one of the pi has gone outside. So yeah, that should be the answer, correct? Yes, that's the answer. That's how you do it. Final minus initial area, just find the change in area. Excellent, very good. So the concept was to make sure that the length of the wire remains constant. Based on that, find the side length of the square, because if you do not find the side length, then there is no way you can find it out. You have to assume that the length of the wire is constant and you change the shape. Cool. Second last question on your screen now. Come on, should I give you 1 minute to solve this, because this is an easy question, I guess. Come on, my warriors, figure this out. Question is on your screen. There is a circuit of resistance 100 ohm connected to 200 volts 50 hertz AC. When capacitor is removed, voltage goes ahead of current by 60. When inductance is removed, current goes ahead of voltage by 60. What will be the current before, when all of them are connected together? So what is the current in the circuit when everything is together? Let's see how many of you can get this. Come on, my warriors. Second last question on your screen now. When you remove the capacitance, voltage goes ahead of current. When you remove the inductance, then current goes ahead of the voltage by same amount. What is the current in the circuit? Oh my god, A and B are the same option. So maybe A and B are not going to be correct. Glad to know that. And Lakshmi, please stay motivated like this. Yes, don't worry about it, Devashri. Most likely A and B are not going to be correct. Probably a printing mistake. Okay, come on, my warriors, figure this out. Okay, hardly any time left. And what do you think? Franz just told something and it is D. Yes, it is D. What is the reason behind that? See, in that phasor diagrams which you draw, where this is VR, this is VL, this is VC. Now, the first time what is happening, capacitor is removed. Only inductor and resistor are there. So when VL and VR are there, then the total voltage leads by 60 degrees, the current. Second time, this is the first scenario. Second scenario, inductor is removed, only VC is there, VR is like this. The current leads the voltage by 60 degrees. Can't you see from these two diagrams that VL and VC will be equal, guys, because of symmetry? Do you see symmetry? From this, can you not see VL is equal to VC? And when VL equals to VC, what happens? It is resonance. It's a resonating circuit. Therefore, the total EMF will be here, and obviously the total current will also be here. And in that situations, I will be just E by R. And what's the value of E? E is given to be 200 volts. That's the total voltage across the total circuit. Remember, yes. So that's going to be 200 divided by 100, which is just 2 amperes. And where is it? It's D. So there is no need of any formulas As such, most of the times AC circuit questions can be directly solved by vector addition, subtraction and phasor diagrams. So keep this in mind. For AC circuits, it's always all about phasors. Namrata, I'm very good, thank you. Hello, just which? Yes, simple but mistake ho gaya. What if it weren't equal? Then you solve it using normal phasor diagrams. Yeah, just like vector addition and subtraction. There are three vectors or three forces. One force is north, one force is east, one force is south. One force is removed, the net force is here. One force here is removed, the net force is here. So what are those forces? Everything you can figure out. It's not that difficult. It's like vectors only. There's nothing special about it. Okay. There is a voltage source and peak value V0, variable angular frequency. You can change the omega. It's in series with inductor and an inductance, okay, is also given. Resistance is also given. Okay. What is the, what will happen to the brightness of the bulb when omega is increased? Figure this out. When omega is increased. Come on, my warriors. Omega is increased. Well, let's put a timer for this question. Let's see how many of you can get this within 1 minute. All-rounder. You're all-rounder in everything, but you just got late to this session. Rahul says B. Why is Namrata sad? Come on, my warriors. Okay. Nancy, you should look here and there every 15 minutes, every 15-20 minutes, just look at some distant objects, blink your eyes, do those eye exercises. Yeah, and then we are done. You will refresh your eyes. Come on. Okay. 13 seconds to go. B, A, C. You have all the answers out there. A, B and C, but many of you saying B. Let's see whether you guys are correct. Okay, so first of all, there is that inductor resistor connected to the source. Now there will be some current in the circuit. Okay, that current will be basically that EMF E divided by Z. What will this Z be? This Z will be root of R square plus omega L whole square. Now you can see what is happening in the question. Omega is increased. So if you increase the value of omega, the value of Z will increase. Okay? Because of that, the value of current will decrease. Now remember this, whenever the question is on the brightness of the bulb, so basically this is the bulb. Okay? The bulb's brightness depends on I squared R. If I is decreasing, the brightness will also decrease and the power loss will also decrease. That's why the answer is decreases. That's the answer. Beautiful question, guys. What a lovely question. Okay, so that's the last question, I guess. Whoa, yeah. Now, since the examination 4th attempt has been postponed, that means you have one more chance of improving your scores. And guys, you have seen that we all are dedicated teachers just for you, and we are going to modify the crash course so that you're going to get the benefit of the doubt solving till the last date. Remember, no matter when the examination gets postponed, the test series, the replays, the doubt solving, all these things are available till the last day of the examination. So you don't have to break your head. Like other institutes, they tell you, oh, it's only for 2-3 days you can watch the replay. Oh, it's only till July. No, we are giving you free of cost. Extension doesn't matter when the examination is conducted. Classes will be also conducted for 11th and 12th standard. All of this not for 10,000 rupees. Actually, when you use my coupon code, you get 40% off. Oh, actually, there is a new offer going on. This is not even 40%. This is old offer. I think the new offer is even better. So if you just go to our video right now, in fact, if you just check this out, crash course, it's not 40% off, it is 60% off. Look at this. I don't know whether you can see this properly. This is 60% off using the coupon code SHCC. So you get it only for 4,000 rupees for the next 1.5 months. Use it till your 4th attempt right now with all the classes, test series, 20 of them with discussion, doubt solving, everything is given. So you can check out all the details. Yeah. And you also have an EMI option if you want to, but I'm pretty sure you would not use EMI for 4,000 rupees. You will not think about it twice. Okay, come on, go ahead, hit the buy button. In case you have not yet used the crash course till date. Right, so that's it from my side today. Thank you guys very much and take care. Oops, what is this? I think we just went to some random question out here. Okay, this was done anyways. Okay, cool. So just check out the crash course and have a great time. And I'll be seeing you tomorrow for a mega mock test. All 3 of us will be coming together. And glad to know that Nikhil, it's amazing and it has helped you. Very good. Please solve all the assignments. Yeah, please buy the crash course, Tanushri, if you want to improve your percentile scores apart from the rank booster series. Bye bye Jacob, bye bye Deepak, bye bye Alni, take care. Whoa, Albiri, now very good, you got your CSE branch. Very good. Take care guys. Bye bye everyone. See you tomorrow, and then we'll also have formula revision sessions, short series and all of that. Take care. Hasta la vista. Shreyas Sir was going live from Bangalore. Bye bye.